Hey everyone, welcome to this AZ-104, the Microsoft Azure Administrator Study Cram video. With the recent changes to the curriculum and the fact that the Azure Administrator cert is now half of the journey to the Azure Architect cert, I thought this would be a good time to actually create a study cram for this. As always, if this is useful, a like, subscribe, comment and share really is appreciated. Make sure you hit that bell icon to get notified of new content. Now I want to stress my goals for this video are to go over the key technical knowledge areas. This cannot be your only study. Now some people like to watch my exam crams at the start of their study, then they go through other materials, then watch it just before the exam. Some will just watch it before the exam, whatever works for you. Remember, I have chapters all along the bottom of this video and in the description. So you can jump to certain areas of cram if that's what you're interested in. You can come back and watch it at different times. If we actually go and quickly look at kind of the curriculum for this, so make sure you're familiar with this site. Make sure you go and look and understand, okay, what's in it. You can go and schedule from this site. It tells you about skills measured. And what you definitely want to do is look at the exam skills outline. And what ideally we want to be able to do is tick off for each one of these saying, yep, okay, I understand that. Yes, I can do that. What's really, really important for this is you need to really have kind of that hands-on. So you're not going to get this just by, I think, reading materials or watching videos. You actually want to go and get some hands-on experience with this. If you look at the Microsoft Learn modules in that site I just showed, so as part of this site, down the bottom, there's a whole bunch of free Learn modules. I would definitely go through those and actually have some step-by-steps to go and do things. In terms of actually getting that hands-on, I have created kind of a study list of a lot of my other videos. And there's one called Learn Azure in 2021. And that video, if you read the description, actually has a bunch of links to getting free subscriptions and other things as well. The nice thing about this is most of the things we talk about are not really expensive resources. Like you can go and create these things pretty much for free to go and try these things out. Storage accounts, resource groups, subscriptions, even things like a VM. With the free plan, there's a certain amount of free VMs. Make sure you stop it. I can really do a lot of this study without having to really spend money. So I would go through the Microsoft Learn. I also have kind of my Azure Masterclass. So this would really set you up kind of a good place. I think it's about, I don't know, 20 hours of content. And I cover a lot of that. So if you partnered that with the Microsoft Learn modules, I think you'd be good. The GitHub repo for that masterclass has all the sample files, but also has links to deeper dive videos I've done about particular aspects. So if you're struggling with one aspect, you could go to this GitHub and watch those videos. And I have prepared this kind of AZ-104 study list where it includes the masterclass videos, but it also includes some other videos that I think complement it towards the AZ-104. I have one about using the pricing calculator, AD and Azure AD, different types of identity, admin units, RBAC, AZs, disaster recovery. So this is a bit more detail. Sometimes I branch into one of my DevOps masterclasses about containers, so you can get more knowledge about that as well. So there's a bunch of fantastic resources to help you be successful. Go and use them all. Everything I'm talking about here is completely free. So with that, let's actually get going and start going through the content. Now, at the start of everything is identity. And when we think about the cloud, then it's really Azure Active Directory. So we have this Azure AD thing. And that is the identity provider for the cloud services. Now, it speaks cloud protocols. This is an important thing to understand. So when I think about the cloud, well, it's things like AAD Connect, things like SAML, things like WS-Fed. And then for authorization, well, there's things like OAuth 2. So Azure AD just speaks all of those things. And what's nice about these is they're designed really for the internet, because all of these essentially function over HTTPS, i.e. they work really nicely over the internet. Now, if I'm an application and I actually want to go and talk to it, well, there's kind of these RESTful APIs, which again operate over that HTTPS. For example, there's Microsoft Graph. Is a great way programmatically I can go and talk to Azure AD. And what we then have is from this, a whole bunch of services can trust it. So if I have this Azure AD, well, you might have a whole bunch of kind of SaaS applications, software as a service, can use Azure AD for its identity provider. Things like Azure, things like Office 365, well, they use it for their identity provider. So it's really a big piece of what we're doing. Now, the name is Azure AD. This is not the same as Active Directory we have on premises. And this is very important to understand. So if I think about Active Directory on premises, regular Active Directory, that would run on your network. So I had a lot of free-flowing kind of communications. This would speak things like Kerberos. That's a different way I can kind of authenticate. It would speak things like NTLM. It would use things like LDAP to go and actually programmatically talk to it. So it's a completely different set of protocols that really wouldn't work well on the internet. Now, AD has its own set of capabilities. It has like this organizational unit structure, so I can have these nice nested components. But Azure AD is not AD in the cloud. There are no domain controllers. In Active Directory, I probably have identities. I might have groups for my employees in the company. And what is very, very common is you actually use something called Azure AD Connect or Azure AD Connect Cloud Sync to replicate objects into my Azure AD. So this is where the Active Directory is the source of truth. It's where I make changes to the objects, but I can essentially make them available in the Azure AD. But it's pretty much always that flow. I can't create the object in Azure AD and replicate it back to AD. It's flowing in that direction. So that's super common. So we have these then, services can trust the Azure AD and use that. Now, when I use Azure AD, what I will actually get from my company is I will get a particular tenant. Actually, let's do this white color. I will get a tenant. So that's kind of an instance of Azure AD. And there's like a default name that you'll get. And then I can add custom domains. For example, mine might be saviltech.net. So I can go and add custom domains to that Azure AD. And we can see this. So if I jump over quickly, actually close some of these down very quick. Don't need those there anymore. If I was to just go and look at my Azure Active Directory, we can see, okay, this is my basic Azure AD. I can see I've got kind of my primary domain name here that I've added saviltech.net. But if I was to go down the Manage menu, and I can actually from here go to Custom Domain Names, you can see by default, it has this onmicrosoft.com name. But then you can go and add your own custom. Now, when you add the custom, you have to go through a validation exercise. But then, hey, I can create users and use that domain. Now, it's really important to understand Azure AD does not live in a subscription. We'll talk about subscriptions, but Azure Active Directory actually lives outside of the subscription. In fact, what actually happens is subscriptions will trust a particular Azure AD instance. So from right here, if you notice, what I can see is for my subscription, this dev subscription, it's telling me the directory it trusts. So that's saviltech.net. And you'll also notice there's the ability to change the directory. So when we think about the relationship, Azure AD lives outside any subscription. Now when we create subscriptions, kind of this idea here, we tell it, a particular instance of Azure AD that we're going to trust for our identities. So all of the identities in our Azure AD will be able to give permissions to resources in the subscription that we're trusting that particular tenant. Now, also within that Azure Active Directory, you can do customizations. So for example, if I go back to that Azure AD for a second, I can absolutely do things like company branding. So this will show up in a lot of different places, but I can have things like a background image. So I've customized it. Here's my little Saviltech image. When people go to logon screens, I can customize the logo. I can put special messages for people when they go to attempt. I can have little icons, mini icons that will show up. So I can really customize that whole experience. Now, when I think about this Azure AD, obviously it contains users. And there's really different ways I can get users in there. Now you'll notice some of them say this directory synced. So we have this directory synced column. So this means it actually came from an Active Directory via that Azure AD Connect. So I can get users that way, i.e. what I showed in the picture that they're replicating. So if I had an existing AD and I wanted to start using Azure, the most logical thing would be, hey, use Azure AD Connect to synchronize the accounts, and then it's a great experience for the user. But you could also create cloud accounts. So I could create accounts directly in the Azure AD that are not related to any Active Directory account. I can also have guest accounts. So if we think about for a second, well, there could actually be, for example, maybe a different Azure AD tenant over here for a different company, or it could be things like a Microsoft account. It could be like a Gmail account. There's a lot of different options, but I can add those as guest users into my Azure AD tenant. So the authentication, i.e. checking their password, is done by whatever the originating identity provider is for that account. But then I can still control things like authorization, check requirements, and then I could give these objects, all of these, permission on any service that trusts this Azure AD tenant. So that could be Azure subscriptions, that could be Microsoft 365, like a SharePoint. It could be some third-party app that is chosen, that I've configured to trust my Azure AD tenant. So there's all these different types of identities I can have in my Azure AD. So absolutely from here, I could just do a new user and realize this is now creating a user. So this will be a cloud account. I'm creating it directly into Azure AD. Or I can add a guest user. So remember, this is where we are inviting them from some third party. So depending on where the account lives, it could be from an Azure AD, it could be from a Microsoft account, it could be Gmail, it could be Yahoo. There's all these different options that I can actually light up as guest accounts. But this is kind of me adding one at a time. But again, remember, these will not replicate back to my on-premises. You can see here, I have examples of accounts from Yahoo. So I've got one from Yahoo. I've got ones, you can see the identity issuer. So that was from an email. I've got one from Facebook over here. I've got another mail. I've got some from Google. So there's all these different types of identity providers. So it's ways that, hey, I want to collaborate with this person. I want to give them access to things. Now that's one at a time. There's also bulk operations. So I can do things like a bulk creation. So the bulk creation, it will actually give me a CSV template that has all the correct columns I need. I would fill that in with my details and then upload it, and it will then go through and bulk create them. I could also use things like PowerShell. So I could use PowerShell via basically scripting to go and bulk create things. Now, when I think about giving permissions to resources, I don't really want to give it to individual users. What we generally want to do is add users to groups and then give the group permission to some kind of resource. So once again, if I had groups in my AD, they could replicate up to my Azure AD, or I could go and actually create cloud groups, so directly in the Azure AD. And there are some nice things about the cloud groups because I have different options. When I think about, hey, creating a group, there's assigned where I actually say, well, Bob and John and Ollie, you're in this group. Or I can do dynamic, where I can say, hey, here's a set of rules based on attributes maybe of the users, they automatically get added into these groups. So groups are super, super useful. And this is really what we want to use. So if I actually went and looked at groups, we can see I've got different types. And it's telling me this membership type attribute over here. And you can see I have assigned where I'm adding the individuals, and then also dynamic, where it's actually using those kind of rules. So if I looked at assigned, well, the way that works is I'm manually adding members to that group. Whereas if I look at a dynamic, let's look at a more interesting dynamic one, Justice League. So if we actually go and look at the Justice League one, then it has members, but notice the add members button is grayed out. I don't manually add people. Instead, we have dynamic membership rules. And in this case, it's super simple. I'm just looking at the user's job title matches the word hero star. So it could be heroine. It would match as well. So that now gives me the ability to say I can add users, they have different attributes, and then automatically add them to groups. And then I can think about, well, then I grant those groups access to things like Azure roles. Now, there are Azure AD roles as well. There's something special about those. Normally you can't assign Azure AD roles to groups, but what you can actually do is if you do a new group, there's this option, Azure AD roles can be assigned to this group. So if you set that to yes, then it has to be assigned. It can't be dynamic anymore. But now I could assign that group an Azure AD role. So that's kind of a special thing you have to be aware of. So that's kind of my users and groups idea. And then I can think about all devices. All devices can also be known to Azure AD. So if I jump over here for a second, if I now think about my device, so I have some computer, and there's really two different methods of making that known to Azure AD. Because I want to make it known, because maybe then I can check the health state of that device before I let users on that device access resources via conditional access, which are rules that I can enforce on my Azure AD. So my options here is one of the things is I can do a register. So with register, the device becomes known to Azure AD, and I can sort of do certain management. For example, I might use Intune, Microsoft Endpoint Management, to do certain management on the device. I can also do a join. So it's kind of a register plus. Now I can actually log in with Azure AD users. So it kind of takes it to the next level. I can now directly authenticate with accounts that are in that Azure AD. So that's the two differences. So if it was like a user's personal device, it'd probably be a registration, because as a company, I still want to maybe check the certain health, make sure it's not a jailbroken device. Maybe I want certain security on it. If it was a corporate device, well, then I might do join. Then I can directly authenticate with users in the Azure Active Directory. Now, there are different licenses. So Azure AD itself is free, but then I can assign licenses on a per user, per month basis to maybe add additional features. Like I keep talking about conditional access. So conditional access are basically sets of rules I can say that, hey, if you want to access this service, well, maybe you have to be from this location, or you've done an MFA, multi-factor authentication, or your device is healthy. I can set these certain rules. That's a higher up license. So there are these different licenses available. If we go and look at them, if we look at the pricing page, we can see, well, there's the Active Directory free. So with the free, well, I don't get MFA, I don't get app access, I don't get any of those full features, but they're partially included. So I get certain aspects of it. So we can see the things I get with those. So if we expand it out, I get bits of that functionality. But if I really want like the full, all of the different capabilities, we start getting into the Azure AD Premium P1 and the Azure AD Premium P2. But you see, even with the free ones, I still get single sign-on. I do get that basic MFA capability. I can still do passwordless. There's a big, obviously, push for multi-factor authentication, where I'm not just knowing a password, it's maybe something I know, yes, a password, but something I have, maybe a device, something I am part of a biometric, and I want multiples of those. But then we see things like with the premium, hey, group assignment to applications. I have things like conditional access. So if we go and scroll down, hey, now I get conditional access with the P1 and the P2. So we get advanced capabilities, and then with the P2 license, you get additional capabilities around things like, hey, entitlement management. So I can create an entitlement, which is like a package of different capabilities. I get things like privileged identity management, where I can escalate up to a new role. There are advanced identity protection features, there are access reviews, but essentially there's different sets of functionality. One of the really important ones is if I want write back. So you could imagine for a second, I could, with the free SKU, replicate my accounts up this way. And I can do self-service password reset for a cloud account. But if I wanted to do a self-service password reset, I forgot my password, and I want to maybe go through, hey, answer a set of questions or get some communication. If it's a synchronized account, the only way to write that password back is if I have a premium license, kind of a P1 or a P2. So I need to kind of understand those things. Now, when I think about self-service password reset, again, if it's a cloud account, I can do that with the free stuff. And what we do is we go and set up, well, what do we want the users to have to do to be able to do that self-service password reset? So if we jump over and look at the portal for a second, if I actually go and look at my Azure AD again, we can actually see there's this option for password reset over here. And if I select that, I can select, well, which users and groups am I enabling for password reset? I've said all of them. And then I pick the authentication method. So how many do they need to do to perform a reset? 1 or 2. And then I set which ones I'm going to enable to use for that password reset. So I can do things like questions. I can say how many do they have to answer to get it right. I can select the questions. I can add custom ones. So what's your least favorite food? You can kind of put that, do anything you kind of want into there. So then, hey, the user forgot their password. Rather than having to go and call the help desk, hey, they can just go themselves. As long as they've registered and I can control that registration, do I want to require them to register for this and then re-prompt every periodic number of days? They'll then be able to go and kind of unblock themselves and give them their own new password. And I have to be a global admin to kind of set this up. Now, speaking of global administrators, there are roles actually built into Azure AD. So global admin is kind of like the all-powerful role. But then there are other roles. Some of them are app-specific. You'll see things like Dynamics and Office 365 and Teams. And the roles are basically just sets of permissions. You could actually go and look at a role, and if you look at the description, it will tell you the exact permissions that role actually has. But these are all kind of global in nature. These roles here would apply to the entire tenant. Remember I said AD has organizational units, and that's really good for delegation. The users live in that organizational unit, and I'm giving you a role just at this OU. Well, Azure AD is flat. There's no concept of that. So when I have these roles in kind of Azure AD, normally they are kind of global in nature. But there is something called administrative units. So what administrative unit lets me do is I can actually kind of create this administrative unit and then add users into it. They're not moved. It's almost like joining a group in a way. And I can add users and groups into an administrative unit. So then the roles also for a subset can be granted at the administrative unit level. So if we go and look at that for a second, we can kind of see, hey, administrative units. I created one called Justice League. I could put users in there. I can also put groups in there. But here's a super important point. I can then manage the group. I cannot manage the people in the group. And you might say that's kind of weird, but it's really logical, because what I'm essentially going to do at this point is I'm going to delegate. So I'm now going to give these kind of certain roles permissions to this administrative unit. So I can say, hey, someone maybe can do a help desk functions for this administrative unit, and I would add an assignment to there. But imagine if I could also manage the users of the groups that are added. Well, I could go and add people to that group, and then I've now got admin permission on them, which would be a really bad security thing. So administrative units, adding groups means I can manage attributes of the group, but I don't get management of the people in the group. I have to actually explicitly add the users into the administrative unit if I want to be able to manage those users. Someone else has to delegate that to me, because it stops me adding users into the group so I can manage them. So that's kind of a whole point around that. And I have to be a global admin or privileged role administrator to manage that. So, and the regular roles would still have permission as well. This is just a way I can delegate. So if you saw something like, hey, you have a help desk, they need to be able to do password reset on these group of users. Hey, I'm going to put them in an administrative unit and then grant the role at that level. So that's kind of the Azure AD level. When we start thinking about Azure, we have different kind of constructs. Now, the most obvious construct we have is really this idea of a subscription. So I think about the idea that I have one or more subscriptions. So maybe this is my kind of subscription one. And remember what we said, each subscription trusts a particular Azure AD tenant. And it's those users or groups within that tenant, albeit how to give permissions to the various resources within that subscription. So that's kind of the key point. I can also have kind of a different account structure of enterprise agreements. So people can be account owners that can then go and create subscriptions under that. I can get a subscription through a reseller, through a partner, even there are free accounts. There's many different ways I can actually go and get subscriptions. A key thing to remember is Azure, like most cloud services, is consumption-based. I pay for what I actually use. So I pay for the seconds that VM is running. I pay for the data stored in that storage account or data stored in that database. So we'll hear time and time again about auto scale, changing the number of instances we have of things to really match the demand so we can optimize the amount of money we're actually spending. So that's kind of a key point. If you're ever curious about, well, what am I spending? So there's a really good cost analysis solution. So if we were in our subscription, we can kind of go over here to cost management and billing down here at the bottom. And then there's cost management and there's cost analysis. So from here, I can kind of see, well, what am I spending? I can see the breakdown of how I kind of spent it. I can see how I spent it based on locations, based on resource groups. I can view differently. I can say, well, what are my daily costs? So I can break this down to see what am I spending on kind of a daily basis. There's many different views into that. I can also create budgets. And the whole idea of budgets is, hey, look, I want to be able to track how I'm spending. And there's two types of budget I can actually create. So there's the idea of a budget based on how much I've spent. So if I edit this budget, I can set alerts. And we can see one of these alerts is actual. So what I've got here is if I spend 80% of my budget based on the budget I set, it can do actions. For example, I could email, I could call a function which does some piece of work. Or there's forecasted. So the point of forecasted is it's kind of looking at how am I tracking? So what I'm saying here is, look, if I think I'm going to spend more than my allotted budget, notify me. Because remember, it's tracking that. If we go and look at our cost analysis, we can actually see what it forecasts. So if I look at my, for example, let's go previous. Let's look at this month. Notice it's actually got kind of an estimate. It starts guessing what it thinks I'm going to spend. Now, I'm near the end of the month anyway. But they're estimating based on my previous usage what it thinks I'm going to spend. So those budgets are really useful, not just to say, hey, how much you spent, but how much I could do a forecast budget. So, hey, if you think I'm going to spend above it, notify me early so I can start taking corrective measures. Maybe I shut some things down, maybe I shrink something. You'd also see there's advisor recommendations. So this would be things like, hey, resize something. Maybe this is too big based on what it's actually using. So those can be really useful. And there's actually a whole separate advisor section where I can get advisements about cost, security, reliability, performance, operational excellence, all of those different things. So that's just a useful thing to be aware from the cost perspective. And don't forget about the cost calculator. Again, there's a separate video on that in the playlist for this AZ-104 where I talk through how to use the cost calculator to estimate what do I think my costs will be. And I'll probably show this a little bit later on. Okay, so I create this idea of a subscription. And again, I can have multiple subscriptions. Within the subscription, we actually create resource groups. Now, I can have more than one resource group in a subscription. So maybe this is resource group 1. There could also be a resource group 2 and a 3 and a 4, etc., etc. And it's into the resource group I actually create resources. Now, maybe I'm creating kind of a load balancer. Maybe I'm creating some VMs. Maybe I'm creating some disks that's being used by those VMs. And a resource group, I think about putting things together in a resource group that have a common lifecycle. They're going to get created together. They're running together. Ultimately, they might get deleted together. So I think about grouping those all together. And what's nice is these will have a common management. Again, I can set roles and permissions at kind of these levels. Those budgets I talked about, well, I can apply a budget at a resource group. I can apply a budget at a subscription. And sometimes there's actually going to be, I have lots of subscriptions in my company. I don't want to have to think about assigning something at an individual subscription level. So in addition to this idea of subscriptions and resource groups, there's actually this idea of management groups. Now, at the root of your Azure AD tenant, there's kind of this idea of a root management group that ties to my particular tenant. Then under that, I can create a whole hierarchy of management groups. Maybe there's a dev, maybe there's a production, then maybe I break it down by locations. And then under there, ultimately, I have subscriptions. So what's really useful is when I think about like the budgets, well, hey, yeah, budget, I can assign a budget at the subscription level. I can assign a budget at, a resource group level. But I could also assign a budget at kind of the management group level as well. And it gets inherited down. So those are really kind of super useful to help him manage and plan my spend. Now, in terms of management as well, one of the really important things you'll see time and time again is the idea of tagging. And a tagging is nothing really more than a key value pair. But I can apply tags at subscriptions, at resource groups, at individual resources. And it's a way that I can do things like find, I can search for resources. I can easily, from a billing perspective, kind of see these things. It's a way for me to add metadata to some object. So here, if I looked at my subscription, well, there's tags. I could add a tag, which is some name that it's custom, and I put in some value. I could likewise, if I just go and look at my resource groups, if I just pick some resource group, trying to think of one where I might actually have some tags, I can add tags to here as well. So maybe cost center is a very common one, maybe created by, date. And then the actual individual resources as well, I could just go and select some base resource or a Cosmos DB account. Those can also have tags. So you can see I've got some in here. Account type, cost center, there's a default experience. So we have these tags, which is the ability to add metadata. Now, one of the key things, most things I've talked about get inherited down. Tags do not. So if I set a tag at the resource group level or the subscription, it does not get inherited to the child resources. So resources in the resource group would not get that tag. Now, there are ways I can accomplish that. There's things called policy, and policy is a way to really kind of set guardrails, which we're going to talk about in a second. But I could use policy to say, hey, look, if you're missing a tag, copy it from the kind of parent resource group. So let's go back to that a second. So if I went and looked at my policy, and we looked at the various definitions we have, if I just quickly searched for, let's say, inherit, notice it has different options. Inherit a tag from a resource group if missing, or just inherit it, or inherit it from subscription, or only if it's missing. So in that way, basically what I am doing is I'm essentially copying a tag from a resource group or subscription to the resource itself. So I'm kind of doing that thing I just said you kind of can't do. But it's saying I'm manually doing. Now, I just said the word policy. And the whole point of policy is in the old days, when we would create resources, let's say it was on premises, I would go to some IT admin and say, hey, I need this VM or this database. They would check my request and make sure I'm meeting company requirements. When the cloud, it's really a lot of self-service. It's a lot of automation. It's a lot of pipelines. So there's not some human doing that inspection. So what we need are kind of guardrails. So we need policy that says these are the acceptable things. Maybe it's the regions we can use. Maybe it's types of account. Maybe it's agents we want present. There's all these different things I can do. So I create these policies. And so the key point here is, remember those budgets I can apply at all those regions? Well, another key thing I can apply is policy. So I could apply policy and they get inherited down. I could create it directly here. I could create it here. So I create policy for what are the key kind of conditions I want to be enforced. And these are enforced at kind of this core Azure Resource Manager, which is the API that everything goes through. I'm using the portal or PowerShell or CLI or templates or some RESTful API. It's going through the Azure Resource Manager. That's where Azure Policy takes effect. And that policy could do things like just track it. It could enforce it, i.e. stop me. It could even maybe remediate. So if there's something that's out of it, it could actually go and fix it. And so what we do with policies, we can create individual policies. You can kind of see these are individual policies here. And if I just take this out for a second, there's massive numbers of policies, so many. What we'll typically actually do is we'll create an initiative. So an initiative, you can see here, has got a certain number of policies in it. So it's the idea of, hey, I have all of these individual policies that are based on some particular attribute. They're known as attribute aliases of my resources, and they have the valid values I'm allowing. But now with these initiatives, it makes it much easier for me to say, hey, I'm going to take this initiative. Look at this list. It's made up of 991 separate actual definitions. So I wouldn't want to manually assign all those to anything. So it makes it easy for me to actually go and assign. But the nice also thing is, you can kind of see some of my assignments I have here, but I can track compliance. So these are super useful. So I've got ones here about allowed storage account types. I can see, yes, I'm 100% compliant on the amount I've specified. There are things like Azure Security Center actually has its own built-in initiative to go and track the overall security of our subscriptions. And when I do an assignment, let's say I've got this allowed locations, I actually specify what my allowed values actually are. So if I edit the assignment for a second and look at the parameters, here, as part of the assignment, I've selected, out of all the possible locations Azure exists, which ones I'm going to allow. So if I try to create something outside of these, well, depending on my configuration, so I've got policy enforcement enabled, it would actually stop me. As if it was disabled, it would then just kind of report. You can always kind of go and look at what those actually mean if you're not sure. So these are everywhere. But notice I can still do that compliance assessment. So if ever you're not sure, hey, you can kind of, it will generally try and give you some kind of help. So policies are super powerful to set those guardrails. And again, there were some initiatives built in. There are a huge amount of policies built in, but I can absolutely go and create my own policies. I can create my own initiatives to really focus in on my exact requirements. Now, when I think about all these different types of resources I'm actually creating, remember we have the whole idea that, well, we have users and groups in the Azure AD. I don't want everyone to have full control of everything. We probably want different people to have different sets of permissions on different resources. So it's something called resource-based access control. And that says, hey, I can think about there are roles. So I have this idea of some role, and a role is really just kind of a set of permissions. And then I have some kind of identity, i.e. a user, a group, a service principal used by an application. And then I have some scope. And essentially I'm assigning a role to a certain identity at a certain scope. And that's what we call a role assignment. And I can do those scopes that I'm talking about here. Well, guess what? That scope, hey, it could be a management group. And again, it's inherited down. It could be at a subscription level. It could be at a resource group level. I can even do it directly on resources. We don't tend to do that because it's just really, really ugly to actually try and manage that. And we can see these. So if we go and look over, and again, these are separate from Azure AD. So if I was to look at just a resource group, if I just pick any kind of resource group, there's this access control option here. And what I can then see is all the different roles that exist. Now, because it's a resource group, well, nearly every role could apply because it could contain any type of resource. So I'll see a huge number of roles. If I was to pick a specific resource, like a container registry, and look at its access control, they'll have a smaller set of roles because a lot of them won't apply. Obviously, a subscription would have the same thing. But I can go and look at one of these roles. And there were some key ones like owner, contributor, and reader. Those kind of show first. They're more generic. Owner can do anything, create anything, change permissions. Contributor has pretty much the same permissions as owner, that it can create anything, modify, but it can't change permissions. And then reader, hey, it can view things. But then there were all these other still these built-in roles specific around certain types of resource. You can add custom roles. So you notice here, I actually added a custom role. Because a role, let's just look at one of these built-in ones. We'll look at a virtual machine contributor. So if we scroll over and view, it's just a list of permissions. So there's all these different permissions it can do. And so I can create a custom role, and I could just say the actual permissions I want it to have. Now, a key point is these are mostly at the control plane, and that may seem kind of confusing for a second. So if I think about Azure, we have this whole idea of Azure, and the interactions with Azure are typically kind of I mentioned the Azure Resource Manager, and that's really about control. I want to create a resource, stop a resource, start a resource. Then the actual resources that live under it, well, they have different capabilities. They might have different APIs, different types of interaction. So these are more the data plane. I create an image file in a storage account. Well, that's an interaction at the data plane. So you see this kind of idea of a management control plane and then actions at the data plane. And what we're seeing here is it separates those. So I'm looking at regular actions here. Well, that's the control plane. But sometimes I'll see data actions. Now, it's not showing me any because the virtual machine has no data plane operations. If I was to go and look, so there were some special ones around storage. So here we can actually see these data roles around blob, queue, and table. If I was to look at one of those instead, just go down and let's select one of those. There are still control plane permissions, but now there are actual data permissions as well. Hey, I can actually go and look, query table entries, the data in the actual object. I can insert, merge, update, replace. So when I think about permissions, more and more now at the data plane as well, I can do that through the Azure role-based access control. And I can absolutely create my own custom roles. Now I can give it a name. I could clone an existing role. I could use a JSON, a template file. I could start from scratch. And when we create our own custom roles, there's really the idea of kind of actions and not actions. Because if I add permissions, I might add some very generic set of permissions. If I did like network, where's the network resource provider? There you go. There's a huge number of permissions in there. And I could just say, hey, look, add all of them. So I've got this massive number. But then you could also exclude certain permissions. So out of those, I don't want it to have a certain set of permissions. So you can go and create those. So it's that whole idea, if you think about when I create my own custom role, so yes, there's a huge number of built-in roles here. So I can think, hey, there's built-in. There's also this idea of custom. So these are all built off the resource providers which give Azure its functionality. And there's the idea that, hey, I can have actions. And I might say something resource provider 1.star. And what resource provider 1.star actually gave me, for example, is maybe there's a bunch of sub-actions on here which gives me 1, 2, 3, and 4. But then what I could say is, hey, I'm going to do a not action, resource provider 1.3. So I'm essentially taking that one away. So the sum set of permissions that role would have, well, would be 1, 2, and 4. So that's the idea of creating my own custom roles. And again, they just come together. So I have a certain role, I give it to a certain identity. So this again could be a user, it could be a group, at a certain scope. So a management group, a subscription, or a resource group. Or you can even do it at a resource level. That's really kind of ugly. It's just hard to manage. If I do permissions at individual resources, it's really hard. And likewise, I don't really want to do it to individual users. Ideally, we want to give a group, a role, kind of one of those. There'll be more generic permissions higher up the management group chain and get more specific as I get to like resource groups. That's typically the way you're going to see those things come together. And again, remember they're different from the Azure AD roles. When I think about what's happening, who's maybe changing permissions, there's an activity log, and we will come back to this later on. But if I was to go and look at my subscription, one of the nice things we actually get is an activity log. So this really shows me everything going on at that control plane with Azure, with this subscription. So anything under this subscription, hey, I can see everything going on. So Sunday, I can see hey, there's kind of one going on right now. And you could kind of get the details around that. So we have all of these. Likewise, I could go to a particular resource. So if I now maybe instead of that went to my storage account, now it will just basically trim down the activity log to only those things against this particular resource. And see, it's adding filters. So it's automatically, when I selected activity log, it added a filter just for this particular resource. So it goes and does those things. But this is things happening at the control plane, not the data plane. This is not saying, hey, I created an image, I deleted an image. None of that would actually show in these kind of things. So we have this rich way to go and interact and see exactly what's going on. So if I was curious about roles, well, one of the filters I could add, for example, would be operation. So I say, hey, operation, and if I type in role, I could see people created role assignments, people deleted role assignments. So if ever I'm curious about, hey, who did something? Someone has permissions, who did this? I could go and look at the activity log, add a filter for operation roles, and then actually go and see those things. Okay, so great. We have subscriptions, we have all these permissions and all these nice ways I can manage it. I mentioned locations before. So we have this idea of Azure, and I drew it as this kind of cloud, but what is it really? So there's kind of a joke. There's no such thing as the cloud, it's just someone else's PC. So if I think about Azure as this service, when I create a resource, most of the time I pick a region. So you can really think about Azure is this huge network around the world. And then there are essentially regions, lots and lots of regions that are connected to that. And a region is really a latency envelope, i.e. it's different physical buildings within a certain distance, kind of 2 milliseconds. So it's made up of different data centers. Maybe it's 16, maybe it's 2, kind of varies, it's easy to draw 3. But this would be a particular region. So for example, maybe this is East US 2. Maybe this is West US 3, whatever that might be. So there are regions all throughout the world. Now there are actually different clouds. So we think about, we just say Azure. We generally talk about the Azure commercial cloud. But there's also like a Gov cloud. There's a China cloud. There's a Germany cloud. And we can kind of see those. If I open up VS Code for a second, I can list my environments doing this get AZ environment command. And you can notice what it's showing me here. Sure enough, there's the Azure kind of commercial cloud. I can see the China cloud, the Gov cloud, the German cloud. So they have different endpoints. It's the same Azure code, but there's different buildings and different networks, and then the different endpoints that actually talk to them. So when I'm talking about this, I'm talking about, hey, we're dealing primarily with the commercial cloud. And so yeah, when I create things, I pick a certain region where I want that VM or that storage account or that database to actually be created under. And my subscription, I can use pretty much any region. There are, again, some of them are locked to maybe certain land areas, but for the most part, if I have a subscription, I can create things in US regions, Europe regions, all throughout the world. Now those different physical facilities, and we'll kind of come back to that, but sometimes you'll actually see them exposed to you. So you might see the term availability zone, and you'll see an AZ1, an AZ2, and an AZ3. These are logical mappings, but essentially within my subscription, these availability zones have independent power, calling, and networking. So it's all about the idea of something failing. So if something failed in a particular building, like power, calling, or networking, it shouldn't impact those things in the other buildings. So if I'm creating my resources, ideally, I would kind of distribute them over the 3 availability zones to minimize the chance of anything going down. Or if something happened at this building, hey, 2/3 of my stuff is still running. You'll see different terminology for these things. Now, when I think about this zone resiliency, you'll see the idea of something called zone redundant. So zone redundant means it is distributed for you. It's resilient. That could be something like a standard load balancer or a standard public IP. Then you might see the term zonal. Zonal means it's in a specific AZ. I.e., if it's zonal, I create it in AZ1. So to be resilient, I'd want to create another instance in AZ2 and another one in AZ3, etc. So there are massive numbers of regions. And there's a nice little infrastructure map. Let's kind of load this up quickly. So this is a picture of the globe. And we can kind of see, and we can filter this. We'll change the filter. And we'll just show, actually networks is interesting, but we'll turn off those things. So we can kind of see the regions. So each of these dots is a particular Azure region. So we can see obviously the US, lots in kind of Europe, Asia, Australia, there's China, Korea, all of these different regions. And we can see this massive Microsoft network that Microsoft owns and operates, one of the biggest networks in the world. Now, this is kind of a flatter version of that picture. We can see all of those regions available. Now, not all services are available in all regions, but there's kind of like a set of core resources that are available everywhere. Those availability zones I talked about. Well, if I look at this picture, again, it's showing me all the regions right now in the United States. It shows me availability zones presence. So this is where I can go and check, do AZs exist? And we can see most of them are available with 3 zones. Some of them, hey, it's coming soon. Some of them it's saying, hey, I don't have this right now. Nearest is somewhere else. So we kind of get those different options available to us. Okay. And likewise, you can go and actually look at which services are actually available. You can dive down and see what's available in what region, etc. You can see explore products by region. Then I can say, well, what product do I care about? And it would show me where it's available in which regions, etc., etc. So if I think about regions, when I'm picking my service, like which region to use, who's consuming it? If I have customers on the East Coast, I'll probably pick the East regions. From a real disaster recovery perspective, I don't want all of my instances in one region. It's super unlikely, but something could happen at a regional level. So I want to make sure I have instances in at least kind of 2 regions. Ideally, from a DR perspective, I want these hundreds of miles apart. Because if there's some natural disaster, I want to make sure it can't impact both of them. So Azure itself has certain services that do this kind of it's always asynchronous. I'd say always, there's a few exceptions, between regions because it's a big distance. So asynchronous means, hey, I acknowledge the transaction and then copy it as quick as I can without impacting the performance of the workload. So some services have that natively built in, like storage accounts. It can kind of have a native replication capability. Azure Key Vault. And so there's a whole number of these kind of paired regions. So we can go and look at this document, and all of these are linked in the description below if you want to go and look at these yourself. But they have this idea of pairings. So these are the various pairings available. And what you'll see is these are generally hundreds of miles apart, but they're in the same geopolitical boundary. And that's obviously really important when I think about, hey, if it's data, there's data sovereignty or regulatory requirements. I don't want my data in Europe, for example, being copied over to the US. They might break some rules. So you'll see most of the time, there's only, I think, one exception. So I think Brazil south replicates to south central US because at the time there was only one region in Brazil. They are now building out another region. So that would replicate the south central US. So you'd need to be aware of that when I think about, okay, planning out my various regions. So those are kind of the built-in pairings. For a lot of services, you don't have to use those. So for many services, I can pick, hey, I want a replica of my database, a read replica in this region and this region. You have a lot of control. But certain services, hey, there's this native kind of pairing just kind of built in, and you can use those. Okay, so that's the basics around kind of those subscriptions and the idea of my resources and identity and those things. So let's actually start drilling down into the particular types of service we actually have. Why is this drawing? Okay, there we go. So I'm going to start with networking. There's not a kind of a right or wrong order to this, but I just think networking really is kind of the foundation for a lot of what we're actually going to talk about. Now, I recommend, if you look at the playlist, I did an AZ-700 study cram video. So that's 3 hours long. That was designed, AZ-700 is a networking certification. So I go through more detail than what I'm going to do here, but I think it would actually be super useful. So my recommendation would be to go and watch that. Another key point is when I think about networking in Azure, I generally pay for egress. So egress is the kind of data leaving a particular region. But I generally don't pay for ingress, data coming into Azure. There are a few exceptions, like if I connect networks together, that I peer them, I do pay an ingress and an egress fee. So there are some exceptions to that. But for the most part, I only pay for data leaving Azure. So when I think about networking, there's this core building block of a virtual network. So I think about this idea, okay, I have a virtual network. Now that virtual network lives within two essential boundaries. It lives within a certain subscription and a certain region. So I can really think about those boundaries. So a virtual network cannot span regions. It cannot span subscriptions. But those availability zones I talked about, it does span availability zones as to the subnets that I will ultimately break this down into. So just like a regular network, where I break it down into subnets, I will break my virtual network into maybe kind of a subnet 1, 2, 3. I can give them proper names. I break them down into smaller parts. Now, for the address space, a virtual network is always an IPv4 CIDR range. And it can actually be multiple. I can add multiple IPv4 ranges. I can optionally add an IPv6 or multiple ranges. If I add an IPv6, I have to have at least one subnet have an IPv6 range as well. So these subnets obviously take a portion of whatever IP range I use. It's common to use RFC 1918. So very commonly you'll kind of see these as the RFC 1918. So the 1918 is the whole idea of kind of, hey, look, it's the 10/8, the 172.16/12, and the 192.168/16. So it's very common to see those address ranges used, but you don't have to. You could bring your own IP range, but realize if you bring like maybe a public portion of the IP space, it will still be only privately used. It would not be accessible to the internet. So yes, you can bring whatever IP range you want, but it will not be usable to the internet. It will still be classed as kind of this private IP range. When I'm picking my IP range, make sure you plan ahead. They need to be unique. Don't pick the same IP range as I'm using on premises. Don't pick the same IP range as I'm using for other virtual networks that I may want to connect. Use a unique IP space so that I could then connect and route between them. So really think through that IP. For every one of the subnets, you need to think about this from a sizing perspective. So for each subnet, you lose 5 IPs. Now, normally just with IP, you would lose 2. You would lose kind of the .0, which is the network address. and you would kind of lose the .255, which is the broadcast. But you're also going to lose the .1, which is the gateway, and the .2, .3 for DNS purposes. So when you're planning out sizes of your subnets, you're always going to lose 5 IP addresses. So just make sure you bear that in mind for your planning around the sizing. But these are all private. When I think about creating a resource, if I create some resource in here, let's say I create a resource, VM, a container, doesn't matter. It's going to get via DHCP an IP address that's available from that subnet. So maybe if it's the first resource, it's probably going to be a .4. Because remember, I lose the first essential 4 IP addresses, 0, 1, 2, and 3. So .4 will be the first available in there. But this is its private IP. So it can use it to talk to other things on the network, things on connected networks, whatever that might be. But I could not connect to this from the internet. That would not work. Now, they can get to the internet. There's nothing I have to do special. Just by default, things in a virtual network can do outbound to the internet and will get the responses through kind of this stateful native firewall that's just built into the service. And I can restrict that. We'll kind of see that later on. But if I want to make services publicly available, I have to add a public IP. Now, I could absolutely kind of add a public IP, and then I can kind of associate it to a particular resource. We don't like to do that. The reason is now I've got this public IP going directly to a resource. What's better is to use a load balancer, maybe with firewall functionality, because what if that resource is rebooting or it crashes? If I want to make something available to the internet, chances are I want it to be resilient. So I'd have multiple resources behind a load balancer, and we're going to talk about that, and the load balancer would have the public IP address. But technically you can, it's just not something we typically would want to do because it's not the right idea. A public IP is always bound to a particular region. I can't take a public IP and move it to another region. It's not the way the routing works. So public IP lives. There are 2 types of public IP. So if I was to go and kind of look at my subscription, look at public IP addresses. If I create a new one, you can see I can do IPv4 or IPv6 or both. There's standard and basic. So if it's standard, it's always going to be static. So static means it's always going to be the same IP address. If it's basic, well, then it can be dynamic or standard. I can add a kind of DNS label to it. And one of the nice things about standard as well is, remember I talked about that zone redundant? Well, standard is zone redundant. If my region has availability zones, it's resilient across them. And I would always pair it with the same type of SKU load balancer. For example, I would use a standard load balancer. So I can go and create those, and then I could associate that with some kind of service. So I'll close that down. So we create public IPs, and then I can associate it with something. The resource itself, like a VM, has no knowledge of that public IP. Azure is essentially bringing the traffic in for the public IP and forwarding it to that resource, but it doesn't really know anything about it. So resources within the virtual network automatically get a private IP again. It's essentially using DHCP. Azure is acting as that when it sees this starts up, says, hey, I need an IP address. Azure is basically acting as a DHCP server and will give it an IP address from what's ever available in the subnet. Now, some types of service, I need the same IP address every time it starts up. I'm a domain controller, I'm a SQL server, I'm an appliance, I'm using IP-based security, I've got certificates that are tied to an IP address, but may happen. So what I can do is the resource itself, like the VM, is always going to use DHCP. But what I could say at the Azure level is essentially like a DHCP reservation. Hey, this resource, when it asks for an IP, make sure you always give it this specific IP address. So for example, if I was to go and look at, let's look at a domain controller I have in Azure. So if I look at my domain controller and look at my networking, it has a network adapter, and it has an IP configuration. And in that IP configuration, you can specify the IP config. And notice what I've got configured here is assignment static. And I tell it the IP address, I want Azure to always give this resource. So if I need a resource to always have the same IP, I don't configure it within the guest OS itself. It's still set to DHCP. But then I tell the Azure Fabric, hey, always give this resource this particular IP address. So that's really kind of a key point around that. The resource itself is still using DHCP. Now I mentioned there's this boundary of a region and a subscription. Well, what if I have more than one virtual network, but I want them to be able to talk? So we have the idea of peering. And peering can be VNets in the same region, or it can be global VNet peering. They can be in different regions. So now I could imagine the idea that, okay, we have some other VNets. I have VNet 2. It could be the same subscription, it could be a different subscription, it could even be a different Azure AD tenant that it trusts. It doesn't matter. So I've got a VNet 2, maybe I've got a VNet 3. And what I can add is peering. Again, it's either just going to be regular peering or global peering, depending on if they're in different regions or not. They have to be different IP ranges. If this VNet was using the same or part of the same IP range, I would not be able to peer them. One of the nice features that recently just went in preview is I can actually change the IP space of a VNet that's peered now without having to break the peer, but it still could not overlap. There's a tiny permission that I do need to be able to add a peer. This is two directions. I create the peer in each direction. If I have the permissions, I can do it in one step. But for this VNet to establish a peer to this VNet, there's a very small permission I actually have to have. It's a detail you wouldn't need to know in the exam, but I just create a custom role for mine. If I looked at my environment, if I was to quickly look at my virtual networks, you can see this virtual network, I have a bunch of peers. And some of these are actually peers in a completely different subscription that trusts a different tenant. It does not matter. I can do that. But from a permissions perspective, so if I was to look here at my roles, again, this is a tiny detail. I'm spending way too much time on this. But you have this network peering target role. So I created that, and that essentially has one permission in it, peer virtual networks. That's it. That's the permission I need on the network I'm trying to create a peer to. But once I've done that, hey, now I can peer them. Again, they can't overlap. Now, one of the attributes of the peering, you'll actually notice when I looked at these things, was you'll notice they were all turned off. But I had this option of, just pick this one. Hey, use virtual network gateway, none. And kind of there's also this use remote virtual networks gateway or subnet. So I've said none to this particular option here. So this is kind of the important one. And the idea of these settings right here is, imagine I have the scenario where maybe this is like a main hub. So this main hub, I actually have maybe like a gateway. So I actually have a gateway, maybe it's to a site-to-site VPN or an ExpressRoute, it's connecting to other things. Well, what I can actually say is for these other VNets, I want them to use it. So on this end of the peer, I can allow gateway transit. I'm going to let them use my gateway. And on this end of the peer, I say use remote gateway. So what that will do is a couple of things, but essentially now these will learn about all of the IP spaces that the gateway has learned through BGP, and it will now be able to send the traffic through and get to those locations. Another really important point about network peering is it is not transitive. So VNet 2 and VNet 3 cannot talk. Just because they trust the same VNet does not mean they can now communicate. They would have to add their own explicit peer to be able to communicate. Or some of those other settings, I could have like a network virtual appliance in here or something like Azure Firewall. And what I could actually say is, hey, look, VNet 3, to get to VNet 2, talk to this appliance, which will then forward the traffic to VNet 2. So there are ways to accomplish it, but it's not native. They are not transitive. I would have a whole mesh of peers unless I use some kind of appliance actually in there. And when I add these peers, again, the traffic can free flow. There's no native restrictions. They'll all be able to talk to each other. What if I do want to restrict the traffic? What if maybe, hey, I want to restrict, maybe talk to the internet. Maybe I want to restrict certain subnets talking to each other, certain things to on-premises, because by default, all of that will open up. When I add a site-to-site VPN or an ExpressRoute, which is a private connection to on-premises, to other networks, to peered networks, they can all communicate. So to restrict that, we have something called Network Security Groups, NSGs. And NSG is just multiple rules. And those rules are really just made up of I can have a priority. Then I have a name for the rule. Then I have the source. Now there's going to be a source and a destination. Now there's different types and the exact options available will vary depending on if this is an inbound or an outbound rule. But there are things like IP addresses, groups of IPs. There are things called service tags. Again, it may not always be available depending on the direction of the rule and if this is the in or the out. There are application security groups, which is a tag I can put on a network adapter. And it can also just be, hey, the entire VNet. So basically create these rules and then I can add a certain port and then an action. Allow or deny. So I create this whole set of rules. And if we look at these, here we'll quickly just go and look at my NSGs. So there's a huge number of these, obviously. But we could just look at one very simple one. And what you'll see is there's inbound rules and outbound rules. And these ones here, notice I can hide or show default rules. So inbound, by default, it allows any inbound traffic VNet to VNet, so anything within the virtual network. Now, virtual network does not mean the virtual network. Virtual network actually means, why can't I get my whiteboard up? Show me my whiteboard. Oh, I know why. Virtual network actually means the known IP space of the virtual network. So virtual network, that tag actually includes the IP space of this and this, if it was connected to on-premises and those as well. They would all count as the virtual network. And when there's another one called internet, internet is everything that's not the virtual network. So it's important to kind of understand what virtual network means. So this rule basically lets any communication between the known IP spaces. It allows communication from the load balancer and then denies everything else. Likewise, outbound, there are default rules that once again, anything virtual network to virtual network, also anything out to the internet, and it would get the stateful response back, but then it denies everything else outbound. But then you can add your own rules. So you can see here, I added a rule for port 80. So I'm allowing port 80, you can see the port is 80 for TCP. And I'm saying it can come from anything, but only to this particular IP address. So if I add an inbound rule, you can see I have different types of source. So I can do as app security groups, which again are just tags on network adapters. It saves me having to worry about which subnet or IP addresses a resource has. There are service tags. So these represent all different types of Azure service. Azure services have these massive numbers of IP address and ranges they use throughout the internet, almost impossible for me to try and maintain those. So instead, those service tags exist. So here, for example, I could get a list of all the service tags in South Central US and then show me all of the actual IP addresses for storage in South Central US. So these are all the CIDR ranges for storage. And there's actually 48 different CIDR ranges just for storage in South Central US. So you get why I would not want to try and maintain those in my own set of rules. So I'm allowing, in this case, for example, communication from storage to get to my VNet. Likewise, destination, because this is an inbound rule, well, inbound to my VNet is not going to be to a service. It's going to be to a certain IP address or a certain, my just whole virtual network, or, hey, a particular tag I have on network adapters. So I would go and create these whole list of rules that I need for my environment. And then once I create the network security group, I associate it. So I associate it with particular subnets. Now you can also link it directly to a NIC, but that's again really ugly from a management perspective. I don't want to try and manage that. So we generally associate it to the subnet. It's not an edge resource. If I associate it at the subnet or the NIC level, it's actually enforced in the switch of the host itself that hosts that virtual machine or whatever that resource is. So there's no difference. If I apply an NSG at the NIC and the subnet, I'm not doubling my protection. They're all enforced at the same place. So I associate that there. So then those rules would be checked, that inbound and outbound traffic. So that's really kind of a key point. So those built-in rules I can override because they have such a low priority. And I can always go and check what rules are actually being enforced. Let's say I'm like, why can't I get to this virtual machine? This seems broken. One of the nice things I can actually do is if I go back to my virtual machines, and if I just pick a particular virtual machine, I don't know, pick this one. I can look at the networking. I can pick the network interface. So I'm kind of clicking here on the network interface. And straight away it's got this button for effective security rules kind of next to me. So I could go and look at them there. It's also showing right below me inbound port rules and outbound port rules. If I just click the NIC, one of the nice things we have are kind of these effective security rules. And the other really nice thing that you might use as well is this other option for effective routes. So if you start having more complex routing, custom routes, all of those types of things, that is super, super useful to actually work out, look, what is going on? What is the routing actually taking effect in my environment? I can actually go and look at that. So now I can see the security rules that are actually taking effect. You can see why. You can see the exact rule that's doing it. And again, here's the kind of effective routes. I could go and see, hey, the built-in ones, everything else that's happening. So this is super useful for troubleshooting when I want to work out, look, why is this not working? Why can't I get to this thing? Oh, okay, I can look at the hops and the rules and everything else. So the NSG is not a physical edge device. It's a set of rules that's enforced in the virtual filtering platform of the switch where this resource runs. They also operate at layer 4. So if you think kind of the old OSI model, it understands TCP and UDP. So ports has zero clue about HTTP, URLs which have a path in them. It can't do any of that. It doesn't understand really fully qualified domain names or filtering based on a DNS name. So there are appliances in the Azure Marketplace that do that. And then there's obviously a first-party one. So if I want to control traffic based on fully qualified domain names or URLs, I want to encrypt SSL encrypted traffic, I want to filter on certain categories, I want to look for malicious traffic, then there is Azure Firewall. So Azure Firewall is something that I would actually deploy into my virtual network. It deploys into its own subnet. So it's actually called Azure Firewall Subnet, I have to call it, and it's a /26, kind of in terms of the size of that subnet. And it's native. It's a native, highly available appliance. It can span availability zones. And it has a whole set of different capabilities. So like we talked about rules of the NSG, well, this has its own types of rules. It has rules, for example, for destination NAT. So I can think about NAT rules, which is, hey, when traffic comes in, meeting this, send it. Maybe I want to send traffic to a particular virtual machine. It has network rules, which are really just layer 4 rules. But then it also has application rules. And they're layer 7. So that's where I can do things like look at the DNS name, look at the path, decrypt the HTTPS traffic because it can kind of sit man in the middle and actually go and look at this. And the way I would use this is obviously an appliance sitting in a certain subnet. And remember I talked before about modifying the routes? Well, if I want my traffic to actually go through the Azure Firewall, what I would generally do is I'll have something called user-defined routing. So I'll create a routing table. And what I would do is I would associate that routing table. So I create a routing table. And it's basically going to say, hey, look, my next hop is that Azure Firewall. And then I associate that routing table with different subnets and networks. So now if I'm trying to talk to some resource, even if it's in that subnet, it'll actually go via the firewall so it can inspect it and then go to the target. If it was out to the internet, it's going to go to the firewall first. So I'd create the firewall, create the rules, and then I would create a route table to say, hey, instead of going via your regular path, go here first, and then it will go and forward it on. And I could use that to enable that transitive nature. In these VNets, I could say, hey, to get to the IP space of that virtual network, your next hop is actually the Azure Firewall, which would then go and actually forward it on. So I can use it for that purpose. So if we go and look over here, firstly, my firewall itself. So I'm using the newer Azure Firewall. So it uses firewall policies. So this is where I can centrally create a list of rules. You can see I have DNet rules. So hey, if I get certain communications on certain ports, I'm sending it to, so that's the destination of the Azure Firewall's public IP. And I'm sending it to certain VMs in my network. So that's DNet rules. I have network rules, which can allow certain communications. And then I have application rules, which actually understand things like categories, actually different site names, actually different URLs I've got in here. It also has TLS inspection. So I've got special certificates set up so it can sit man in the middle and actually decrypt SSL traffic. And I can go and check for things through there. I can go and see which networks are protected with this. It has IDPS, so it can go and look for certain types of attacks and intrusion. So it's a really powerful solution. And then to actually make it work, if I look at my route tables, I created different route tables that essentially just say, for everything, for this one, your next hop, well, that's the private IP of the Azure Firewall. And then I associate this with the subnets where my workload. Likewise, I have another network. Once again, it's going to send everything to that Azure Firewall. And again, I associate it with the subnets. So now everything they talk about is going to go via that Azure Firewall. So I'm kind of bringing those multiple things all together to accomplish that. And most commonly, I'm going to have kind of an Azure Firewall, at least per region. I don't really want to go cross regions just because of the latency and the performance degradation that would actually introduce. Okay, so that's about restricting and controlling traffic. I mentioned fully qualified domain names, obviously DNS. So DNS is huge. Now, as humans, we're terrible with IP addresses. We're not going to remember those. We like names for things. And so DNS provides that mapping of a name to an IP address. And Azure actually has DNS services both for public resolution and for kind of private internal resolutions. So if I think about kind of the Azure DNS, so if it's a public instance, it's public facing, that's really focused around host records, kind of the A and the AAA, so IPv6, and kind of those CNAME, the alias kind of records. And I'm going to manually go and create those. So I'll go and create a zone, I can add records, great. If it's private, well, then that's just being used internally. So for private, I have actually a bunch of different functionality if it's a private one. So I'm going to kind of draw this as a box. So once again, I can add them manually. So I can add them manually, but it can also have kind of this automatic registration capability. And I have a massive number of different types of records. So there's kind of the A, the CNAME, there's text, there's service, kind of the list goes on, massive number of records available for this. I pick the name of the zone, exactly the same I would for public. I pick whatever my zone name is. But now what I can actually do is I can associate these private zones with virtual networks. And the relationship is this. So for a virtual network, I can configure it to auto-register any resources I create into this zone. Now the registration is such that for registration, a virtual network, that's kind of a terrible R, it's bad even for me, registration. A virtual network can register to one private DNS zone for registration. So I create a resource, Bob, it will create a record in here called bob.saviltech.net. That was the zone name, but only one. Each private zone can be linked to up to 100 VNets. So up to 100 different virtual networks could be auto-registering to this zone. And the benefit here is that now they would have consistent name resolution across different virtual networks. Which brings me to VNets can also, I can imagine there are lots of other zones that I create. I can also register for resolution. I don't want the resources to actually create records, but maybe there's records in there I want to be able to resolve. oli.savtech.co.uk or something. So each VNet can actually associate with up to 1,000 private DNS zones for resolution, and each private zone can actually associate with 1,000 VNets. So I think if I'm a virtual network, hey, resources can get automatically registered into one zone, but I can actually get resolution, i.e. resolve this across different zones to up to 1,000. So I have those kind of associations. Now the way the Azure DNS actually works is if I create a resource like a VM, there is a IP address that just works, that always represents Azure DNS. So there is a 168.63.129.129.16. That is Azure DNS. Always. So if I talk to that, I am talking to Azure DNS, and I will then get all these various resolutions. And of course, Azure DNS will also go and resolve internet zones. It will go and do that for me as well. Now realize that IP address only works in Azure. If I wanted to go and talk to these private zones from on-premises, I'll have to have some kind of DNS forwarder set up. So it on premises, it talks to some resource, a DNS forwarder, and then that DNS forwarder can talk to Azure DNS to actually go and get the records. So these private DNS zones are global. I can use them from any region, any subscription, any VNet, any tenant. I just have to have permissions on it. Again, super, super useful, super powerful. So that's the core about the name resolution. Now, for the next part, I actually want to think about connectivity for a second. So we had this idea that we have a virtual network. This one's getting kind of busy. So let's draw another virtual network for a second. So we'll draw another VNet. You can think of it as not changing anything in terms of the concept of just running out of space. So we have our virtual network. And great, we can peer to things, but we have things on premises. I have maybe data centers, buildings, whatever that might be, that I actually want to go and talk to. And there are really two primary ways I can connect a virtual network to some other network. Now I'm drawing this as on premises, but this could actually be another cloud provider or something else. It actually doesn't matter. But I have some other network, and obviously it is some IP CIDR range. It is represented as some IP range here. So I can connect using a site-to-site VPN, which goes over the internet, or ExpressRoute. There is also point-to-site VPN. Point-to-site VPN connects a particular machine to the virtual network. So if I want to use a VPN, first of all, site-to-site VPN, we have to have a VPN gateway. So the idea here is we have a certain subnet. Oh, I don't want to do that color. We have a subnet. So we have a gateway subnet. Now the recommendation for that gateway subnet is to create it as a /27. It can be a /29, but the problem becomes is, what if one day I want to use site-to-site VPN and ExpressRoute? They are different gateway devices. I wouldn't have enough space. So if you can, unless you're really short of IP space, you want to do this as a /27. Now there are two types of VPN. So I'm going to create this VPN gateway. And they support different types of actual VPN. Now there's one of them is called policy. That's also called static routing. And the problem with policy is, well, I can only have one tunnel. It doesn't support point-to-site VPN. The way it works is it encrypts the traffic and then sends it to the tunnel based on some configured list of address prefix that's allowed to travel. It's only supported by the basic SKU VPN gateway, and it's really not very common. So I would not, and think of this as really this static policy as legacy. Most likely what you're going to do is a route-based, i.e. dynamic. So what this does is it directs the traffic to a particular tunnel and then encrypts it. So now I have support for n number of tunnels. It does support point-to-site VPN. It does support coexistence with the ExpressRoute gateway if you were going to add that. So this is the smarty one. This is the one you're really going to want to use. And what we're essentially going to do is establish this connection over the internet. Now, it is over the internet. So it's going to be a certain speed, and that's fine. It's encrypted, IPsec, so it's encrypted and secure. Latency, it's going over the internet. Now, that could vary. If we actually go and look at the gateways, we can see essentially, yes, there's this basic gateway that is essentially doesn't support point-to-site over here of IKE v2, only the old SSTP. But as you'll see later on in this document, it really talks about this is just not recommended anymore. So we really talk about these VPN gateways, 1, 2, 3, ones with AZ support, these Gen 2 ones. You can see they have different speeds, different numbers of connections. These are still the speeds we can get. So we can actually go up to 10 gigabits per second. And notice we can actually have, how many tunnels can we have? Well, these high ones up to 30 tunnels with that. Now, what's important to realize, so if let's say it's 10 gigabits per second and 30 tunnels, that 10 gigabits per second is aggregate. If I had one connection, it could go at 10 gigabits per second. If I had 30 connections, their total is 10 gigabits per second. So I don't get that per. These are basically VMs. They have a certain amount of computational power to handle their IPsec encryption. So the speed is really governed by how much they can process. So it's not per tunnel. If I add 30 tunnels, they're sharing that capacity of handling that computation. Now, to actually run these, I said these are virtual machines fundamentally. There's actually different models because I can run them if I think there's an Azure side, and then there's kind of the on-premises side. Now, I might just have one gateway on premises, and on the Azure side, I can run my gateways as kind of an active and a passive. So there's one public IP, and so the connection is essentially going to be that. But I can actually run them as active-active. So another option is I could do active-active, where they each have their own public IPs. And likewise on premises, I could actually have multiple gateways. So then I would actually have kind of that very resilient set of connections. Or there's some combination. Maybe I run active-active, but I have one on-prem gateway, so it just establishes those. There are different combinations I can do. So what I'm thinking about here is, hey, look, I create my VNet. I'm going to create my subnet. I create my VPN gateway. I create a local network gateway object, which basically represents this. So there's some gateway here that has a public IP. So I create a local network gateway that gives me the public IP of my on-prem gateway and the IP address range it represents. Then I configure this gateway with whatever pre-shared key and the IP address of this, and then I add the VPN connection. And then I'm happy and I'm connected. The other option to connect is, I mentioned before, Azure has this massive global backbone network. Well, that massive backbone global network obviously connects into all the Azure regions, etc. But it also extends out to a lot of kind of facilities called meet me locations. And then I, with my network, could actually extend into those same meet me's where we kind of cross connect the networks. Now this could be a direct connection. It could be I have an MPLS, and my MPLS provider also can kind of onboard at this point. But with ExpressRoute, what I'm basically doing is I'm connecting privately. So this is not going over the internet. This is kind of private connectivity. Now what I'm doing, I'm connecting my network to the Azure backbone network, the Microsoft backbone network. I'm not connecting to a particular region. I'm connecting my network to their network. Now I might have multiple locations. And actually one of the interesting things I can actually do with ExpressRoute is, hey, imagine I have this scenario. There's a feature of ExpressRoute actually called global reach. So what global reach actually lets me do is, via that Microsoft network, I can actually talk to my own facilities. Maybe I don't have maybe they're different geographies, there's not some carrier to connect them. They each have their own kind of meet me connection of ExpressRoute. They have their own circuits. If I turn on global reach, I pay for that. They can actually now talk to each other over that connection. So that's what global reach is going to do. Whenever I have ExpressRoute, I drew two lines. It's always active-active. I have redundant BGP sessions, so it's very, very resilient. If I do ExpressRoute Premium, I can actually connect to any Azure region globally. Regular ExpressRoute is any region in the same geopolitical boundary. Price is based on the speed and egress. So if I look at my ExpressRoute, I buy a certain circuit. So I pay a certain amount. Notice premium costs more. Inbound is always unlimited, but there's no outbound included. I will pay for the amount of data that goes outbound. Or I can actually pick, there's an unmetered plan. I don't know if I'm not finding it the right place. Oh, unmetered. So here it's unlimited egress as well, but I pay a lot more for the circuit. So those are kind of options available to me. So that's great. This is all about actually connecting to the Microsoft backbone, but I've not actually connected to my virtual network. So what we do on top of this ExpressRoute is if I want to connect to a virtual network's address space, what I'm then actually going to do is something called private peering. Now this time I have to have an ExpressRoute gateway, so it can coexist. And now what's going to happen is it's going to establish over this that connection. So I'm linking this IP space with the IP space of my virtual network. And remember that peering option I had, allow gateway transit and use remote gateway. It could also be for peered VNets, could use this as well. So now I've connected these spaces together. This can be IPv4, this can be IPv6. The same ExpressRoute gateway can connect to multiple different circuits for resiliency. Likewise, a single circuit can be connected to multiple ExpressRoute gateways, i.e. different VNets. Different gateways support a different number of connections. So by default, if I look at an ExpressRoute circuit, this is talking about premium, but only because notice ExpressRoute circuits per region per subscription is kind of 10. But then it talks about number of virtual networks. So it's 10 for a standard, always, no matter what the speed of the circuit. I can connect to 10 different virtual networks. If I add premium, I can actually connect to more. So with premium, I can connect to, as the speed goes up, so too can the number of virtual networks. Likewise, the different virtual network gateways for ExpressRoute, depending on the SKU, it supports a different number of circuits I can connect to. So the minimum is 4, but if I get the really, really big ExpressRoute gateways that can obviously do a higher amount of traffic, higher bandwidth, then I can actually connect to more circuits as well. Key point about ExpressRoute, traffic coming in goes via the gateway. Traffic going out does not. There's no point. It goes straight to the kind of Microsoft Enterprise Edge routers. If you actually looked at the routes, you would see the next hop for this IP space is not the IP address of the gateway, it's the IP address of the Microsoft Enterprise Edge. Inbound, there's a feature called Fast Path. If you turn on Fast Path, and I have to have the ultra gateways to do this, even the inbound traffic doesn't go via the gateway. It will go directly to the target, so it will reduce my latency because I'm taking out a hop as part of the direction. So that's private peering. Now realize there are other resources. There's storage accounts, there's databases, there's all these other things that essentially, as I showed you those service tags, are all available via a set of kind of public IP address ranges. So the other type of peering we can actually do, use the Galaxy pen, is something called Microsoft peering. So what Microsoft peering does is we actually create something called a route filter. Now in that route filter, what we're actually doing is we're listing the services that we want to be advertised over ExpressRoute. So we have this list of the services, and now the IP addresses of those services gets kind of advertised down through BGP, which is how we announce, hey, these routes are available, this is how you get to something. So now, when something here wants to talk to some service that's been offered, instead of going out via the internet, it will go over the ExpressRoute connection. So that's what Microsoft peering is all about. And again, if we look super, super quick, I'm going to shut these down quick, too many tags. If we look at a route filter, so we would create the route filter. And then what we do is we add the service communities, which are really the same as kind of those service tags. See all the different types of service that I could make available. If I check the box, then these communities, which are those groups of IP ranges, would now get advertised as part of this route filter. So I would add all the services I want to be made available, and then I would associate this with a circuit. So then that circuit would use this route filter and would obviously then offer all of those various services. So that's how I would use that. Now, one important consideration just when we do think about kind of ExpressRoute, it is over a private connection, so it's not encrypted. So by default, there is no encryption just natively of ExpressRoute. Obviously, if the service I'm talking to is HTTPS, for example, then it's encrypted. There are things I can do if I use something called direct port, which is where I have kind of my own set of ports at the meet me that I can do something called maxsec to encrypt just over at the meet me location, but that's still not end-to-end. One thing I can do if I really needed that end-to-end encryption is I can actually run the VPN gateway over ExpressRoute. So I could actually have a site-site VPN running over my private peering, so I get that encryption. So that is possible. Now with all of this, you can kind of see, hey, look, I'm setting up peers, I'm setting up gateways, I'm setting up connections, and I can absolutely do that. But there might be scenarios where I really just don't want to get into that kind of business. I don't want to be setting those things up. And so you may hear something called virtual WAN. So this is really a managed kind of black box service where I create this virtual WAN instance. Often I would have kind of one of these per region. And the whole point of what virtual WAN is doing is a managed virtual network, so I don't really see this, but what I can then do is there's two different tiers really of virtual WAN. So there's this basic tier. So with the basic tier, it supports kind of site-to-site VPN connections. So that's kind of the basic. And then there's a standard tier. And so I can also do site-to-site VPN with the standard tier. With the standard tier, I can also add things like, well, I can use ExpressRoute. So again, that's kind of that standard tier capability. I can have things like, remember those, I can have a point-to-site VPN. Again, with kind of that standard tier only. And also, if I have, so the whole point is here is I have different VNets that I would kind of have peered to this. One of the nice things that standard does is it enables that kind of transitive communication between them. The other thing I could obviously do is I might have other virtual WANs in other regions. And so with standard, I get those kind of, I can connect them together. So virtual WAN, the whole point of this is it provides that managed kind of connectivity solution for me. So I don't have to worry about the gateways and connecting things. There's a secured virtual WAN where Azure Firewall runs in here as well. So that's kind of a really nice solution that I can leverage. Now, when I think about routing, another thing virtual WAN does is makes it easy for me to control kind of what component can talk to what component. I showed the idea that I can modify the routes. So that's something that's going to be in the test is user-defined routes. Remember, I showed you the whole idea of those route tables that I linked. So I can modify the next hop. So, hey, normally I might go directly to this location, but a UDR lets me change, hey, I want to make it go a different route. So I can configure those things. Remember, with a with software-defined networking, which is what we're dealing with here, in a physical network, when I have routes, my next hop has to be something typically on my subnet because it's the next place it's actually going to. So I have to be able to get a direct path from where I am to that thing I want to talk to. In software-defined networking, that is not the case. I can absolutely have this scenario, and you saw when I showed you those route tables, my next hop was actually something in an entirely different virtual network. I can do that in Azure. I don't have to have multiple NICs. And again, a virtual machine can only have NICs in the same virtual network. I could have them in different subnets, but I can't span virtual networks with a single virtual machine. So the whole point is, hey, with these route tables, this user-defined routing that I leveraged over here, I can override those default routes. And I showed you before how I can actually go and view those. Now, the next thing I really kind of want to talk about is controlling the flow to PaaS services. So a PaaS could be something like, hey, a storage account, for example. Now, I had the idea of an NSG, and remember we saw those service tag ideas that could represent a certain service. So I could restrict access to maybe storage or SQL databases or Cosmos through the NSGs going in that direction. But I always want to think about, well, what are the other ways I can kind of control accessing services that don't exist within my virtual network? So if I took this example here, for example, and we give it some more subnets over here. So maybe we've got like a subnet 2 and a subnet 3. Remember, there's these other services. So for example, maybe, hey, yeah, I've got another storage account 1. Now, most resources actually have their own kind of firewall native to them. So in front of this, there's some kind of control. So I can control what is allowed to talk to that particular instance of a service. Now, ordinarily, what I would do with that is I could control, hey, from these public IPs, allow or disallow communication. But if I wanted to control access from something in a virtual network, remember, these are private IP spaces. It wouldn't see those IP addresses. So I can't say, hey, allow access from this private IP range. It wouldn't work. So the way we actually do this, there's a number of different means to control access to services. The first thing we can actually do is something called a service endpoint. So the way service endpoints work is basically I make a certain subnet known to different types of services. So I can add a service endpoint for, let's just say, storage, just as an example. So now subnet 2, it can be known by storage accounts. And then what I can say is on this particular instance, I'm going to say I want to allow subnet 2. Additionally, what the service endpoint does is it actually gives me kind of a better route as well. So it knows it's talking to a public endpoint, which is normally via the internet. And even without doing anything, traffic does not bounce out to the internet. Azure is smart enough to know before it hits the internet, hey, actually this service is accessible on my backbone, and it will keep it on its internal network. But there's still going to be some various hops around there. When I add a service endpoint, it actually, you'll see this also in the route table, it adds a special kind of route that says, hey, I know what you're trying to do, here's a more direct path. So service endpoints enable me to make specific subnets that I enable known to types of service. So then on the firewall of that service, I can say, hey, only allow traffic in from this particular subnet. So if we was to go and look, if we look at the virtual networks. So if I look at one of my virtual networks, and I look at my South Central and look at my subnets, I use this infra subnet all the time, this kind of first one. So what we'll see is service endpoints, I've enabled SQL and storage. So on that subnet, I've enabled those two. But there's a bunch of other ones that I could enable as well. And what's that already done? So if we super quickly looked, again, this is more detail than you probably really need to know, but if I was to go and look at a resource, if we looked at networking for that, and we looked at its effective routes, just by adding that service endpoint, what we'll see is a whole bunch of basically address prefixes now. It'll have a special type of communication. So notice these, virtual network service endpoint. So it knows for all of these services that I lit up for that subnet, it has a different, it's not the default internet, it's actually going to take kind of a different route, a more direct route. But the other thing that has now done, because I lit that subnet up, if I now go and look at an example of one of those services, so if I look at my storage accounts, for example, this is where you'll see I can't remember what the right icon is for storage accounts. There we go. If I go and look at one of my storage accounts, that's in here. So what we're doing here is, now this is common across most of the PaaS types of services. But one of the things you'll actually see is we have this networking option right here. Now if I go and look at my networking, by default it just enables connectivity from all networks. If I do selected networks, it's doing a number of different things. But I can add particular IP ranges. You can see down here on kind of the firewall, it knows my client IP, so it can automatically add that, or I could add particular ones. But also what I could do is add an existing virtual network. So at this point, it's going to show me all the various virtual networks in the same region. And then from that, I can then pick particular subnets. Now notice, for that infra subnet I enabled the service endpoint for, it's just kind of available to check. Now what it is offering is like, hey look, this one needs a service endpoint required, but it would actually do it for me. It would actually go and create the service endpoint. So I can do it all in one go. But generally you'd go and set up the service endpoint on the particular subnet, and then I could actually go and then light up on the firewall of that particular PaaS service to actually go and enable it. So that's the whole point about service endpoints. It gives me that ability to make a particular subnet known to all types of a service, gives me a nicer route, and then on an instance of that service, I can then, at the rule level, say, hey, allow this to come in. Service endpoints are not usable outside of that subnet. It's only for resources that actually live in that subnet. So if I'm actually kind of a VM in here, great, I can use that. But if I'm on a peered network or on premises, I can't use that route to go and get there. So then there's another type of resource. So the other thing we have is something called a private endpoint. This is part of private link. So ordinarily, remember, these have public IP ranges. We could kind of see those. So there's a bunch of IPs for a particular instance. So let's take another instance, call it storage account 2, but this could be a Postgres database. It really doesn't matter. It has certain public IPs. What I'm now going to do is I'm actually going to go ahead, we'll use a different color so we can distinguish between these. I'm going to create a private endpoint. So a private endpoint uses an IP address from the particular subnet. It's like a virtual network interface. And it represents a specific instance of the service. Now, the public IP now no longer works. And there's some special DNS. So if I'm using the Azure private zones, it can kind of create these records for me. But now it creates a special private link version of the service that actually points to this private IP instead of those public ones. And because it's just an IP address, I could be on premises through a site-side VPN or private peering, as long as I have this kind of DNS set up that says, hey, for this private link variant of the name, go to this IP address, which is just a regular IP from the subnet, it would actually work. So this can actually be used from all different places. So if we saw this super quickly, so firstly, if I go and look at, let's look at a different storage account. So I actually have a private link demo storage account. Now, firstly, this storage account actually has a bunch of endpoints. So there's a particular name. So you can see there's one for blob, and I'm actually going to copy that. But then what I've done is I've actually added, if I go to networking, private endpoints. So I've actually added private endpoints for the different types of service. There's one for blob, there's one for files, for example. And those get added into a particular virtual network. Now, as you might kind of guess, the actual virtual network I used was my kind of South Central infrastructure. And what you'd actually see is you see all these weird types of things, but it actually just used an IP address. So if we look at the names, so notice these two names here. That's my blob and my files, and they just got IP addresses from that virtual network. So now I can access the service using that private IP. Now the way this actually looks, so this is a virtual machine within that network. And if I did an NS lookup for that regular kind of name, so let me just get that name that we just did, that name, notice what's special. So what actually happens over here is we get this alias to a private link variant of the name. And what you see is it now resolves to that private IP address instead. So I just need consistent DNS resolution. And now when it accesses that, it will just go and use that particular IP address. So it will now use the private link connection instead of having to actually go via some public IP. It's using it from that special zone. Now, the other thing you can actually do here that's super cool is it's not limited to kind of Azure PaaS services. Imagine I had my own service. So imagine for a second I have some other virtual network and I've got a VNet over here. And remember I talked about I can't peer things that had overlapping IP ranges. Maybe this overlaps. But over here I've got some service and it's sitting behind a standard load balancer. I can add something called a private link service. And then I can actually add a private endpoint to that service. I can add it from multiple places. So now I'm adding my own private link enabled service, which again could be accessible to any connected network as well. So it's not just Azure PaaS services. I can really go and add really anything I want. So those are kind of the two ways that I can control access to other types of service from my virtual network. Now, just to a load balancer. Okay, load balancing. Load balancing is super, super important. When I think about Azure, a key point of what we want is normally scale. I want multiple instances of smaller things so that I can delete and add them, so I only pay for what I need with any kind of amount of work coming in at any one time. So what we'll have the idea is, though, I don't want to give clients, so someone using it, different IP addresses, for instance, 1, 2, and 3. So we need a load balancer. So that load balancer has some kind of front-end IP address that the client can go and talk to. Now, the first load balancer, very simply, is the Azure Load Balancer. Now, this is a layer 4 load balancer, i.e. it understands TCP, UDP, the idea of a port, has zero clue about HTTP, HTTPS, any of those things. So it's kind of the protocol, the port, and then I can think about, well, I understand the destination and the source kind of IP address. That's what it is really basing things around. So I have a front-end IP, and what I potentially want to get to is I have pools. I have a back-end pool 1, which has got different resources in it, offering a service. Maybe I've got a back-end pool 2, which links to a different resources, maybe different websites or something. Some service. So then what we have is we actually have our load balancer. So we create our load balancer. And what we have on the load balancer is really just rules. So we have sets of rules. And the rules are really just based around the idea of, hey, I have a hash-based distribution So I'm distributing, and it creates the hash based on 5 protocol port, destination, source, and the port on each time, 3 or 2. So I have these different kind of distribution options of 5, 3, or 2 tuples. I.e., again, destination, IP and source, IP, ports on each side, and then the protocol. So if I have to match on all 5 of those, so the source IP and source port and destination IP and source port and protocol all have to match, that's 5 tuple. But maybe I say, I don't care if the port changes. So it's just the destination IP, source IP, and the protocol. That would be 3 tuple. 2 tuple would say, I don't even care if the protocol changes. As long as the destination IP and source IP are the same, match. So it's how sticky I want to be with whatever that distribution is to that backend set. So we have these distributions. We also have the idea of a NAT rule. And a NAT rule really is just kind of a certain port goes to a specific resource. i.e., hey, this port, make it go RDP to some virtual machine over here. There's also health probes to go and check if they actually exist. But essentially what these rules are doing is saying, hey, this front-end IP, if it matches these things, I want it to go to this particular back-end pool. Now, these front-end IPs are either internal or external. So it's an internal load balancer or an external load balancer. It cannot be both. I can have multiple IPs, but they're all of the same type. Either they're all internal from the virtual network, or they're all public IP addresses. If I want to be able to offer things internally and externally, I'd have 2 sets of load balancers. So we can kind of see super quick. If we jump over and look, then we look at load balancers. I have a super simple load balancer here. I have a front-end IP, so this is external. It's a public IP address. I have a back-end pool that's made up of a virtual machine. I can pick how I'm checking for the health. I have load balancing rules. So I'm doing IPv4, TCP. You can see the mapping. Session persistence. So notice I can take just client IP or client IP and protocol. So that's kind of the 5, 3, and 2 tuple options that I can kind of do from there. And various other more advanced options that I talk about in other videos. It's a bit too much detail than what I want to cover in this cram. But basically, hey, I can map all those different things together through there. If I look at this rule, my backend pool, I've got 2 resources. And there is both kind of a free and a standard version of the load balancer. So if it's the free one, then I can have up to 300 backend resources, but they have to be either from the same availability set or the same VM scale set. Also, there's no paid SLA because it's a free resource. If I do the standard, then it's up to 1,000 in the same VNet. And I can actually point to IP addresses, or I can point to kind of NICs. It has availability zone support. So I can be like zone redundant or zone, or I can pin it to a certain one. So I have different options actually for this, for that load balancer. So that's my basic load balancer right there. That's my layer 4. Again, we have those different capabilities. And remember, I must match the SKU. So this is a public, and this is a standard. I have to have a standard public IP to go with my standard load balancer. You really kind of have to bring those all together. So that was a layer 4, but then also we have the idea of kind of a layer 7. So remember, layer 7 would really be the idea of, hey, layer 7 is I understand HTTP, HTTPS. I understand WebSockets, HTTP2. So I have all these kind of different things. And if we're staying as a regional solution, i.e., this is resilient at a region level. This is not a global resource. The solution here is Azure App Gateway. Now it's important to, like if it says, hey, this is a HTTP site, I want to try and use the best load balancer, because if it understands like HTTP, I can do things like session-based affinity, SSL offload. I can do routing based on the URL on the fully qualified domain name. So I get additional capabilities. So if it says, hey, I have a HTTP workload, what load balancer should I use? Could I use this one? Sure, but I don't get any value add capabilities for HTTP, HTTPS to WebSockets. Whereas this I would. And some of the concepts are similar once again. Again, I have kind of the idea of a front-end IP. Now this time, I always have a public. Optionally, I can also have a private. This actually deploys into my virtual network. Now the way this kind of fits together is obviously an IP has lots of different ports. So what we create is a listener. And the listener is tied to a particular kind of front-end IP configuration. On the listener, I can perform certain configurations. Hey, do I want to do, for example, SSL offload? Certificates I'm kind of using. There's also different types of listener rules. There's kind of a basic rule that says, hey, everything to that, I'm just going to send you to a particular rule. Or there's actually multi-site listeners. So a multi-site listener, what it lets me do is I can essentially use the same, I can have multiple listeners using the same front-end IP. And what I can now say is, hey, based on the fully qualified domain name or part of it, go to a particular rule. But a different fully qualified domain name, go to a different rule. So I can route things differently. So these use rules. So this uses rules. And the whole point of the rules is basically, hey, again, there's those basic rules, there's path-based rules. So I can actually look at the path. And one of the great things this can do is I can do that, do the SSL offloading. So I can actually then see the path, which is part of the URL after the fully qualified domain name, and then route. So if it's going to blog, we'll go to one set of backends. If it's shopping cart, go to a different set of backends. So I can do that. I can even do a rewrite. I can change part of the URL to make it behave differently. There are things like HTTP settings. And those HTTP settings actually tie into those rules like affinity, encryption. But ultimately what happens is, once again, I have different backend pools. And so based on those rules, based on URL, whatever those things might be, I send it to different groups of resources. So we have a whole bunch of nice capabilities. The standard V2 SKU of the App Gateway has things like auto scale, zone redundancy, or it's zonal, but it's all those really same components. These backends can be a virtual machine scale set, an IP address, a fully qualified domain name, an app service. It can even be on-premises resources. I'm accessing via kind of a site-side VPN, ExpressRoute. It could even be a public endpoint, a public IP. Once again, there's health probes going in on all of this and all these various capabilities. If we quickly jump over, so if I go and look this time at my App Gateway, we can see I've got one. And we can see all those different things in action. So we have the idea of a front-end configuration. So it has a public and a private. I have various back-end pools. So we're going to have got a couple of virtual machines for my back-end pool. Then we have the idea of the HTTP settings that, remember, is used by the rules. So different types of affinity options in there. Then I actually have my listeners. So I've got a kind of a basic listener, then I have the multi-site, and in the multi-site, notice we give it parts of the URL, so we'll call different rules based on parts of the fully qualified domain name, Then we have the rules themselves. Then in this case, hey, for this listener, send it to this group of backends with this particular HTTP settings, and all that good kind of stuff. So there's a whole bunch of options there. There's actually a nice feature in the portal. If I just type load balancing, help me choose, it has this really nice service comparison. So it shows me, hey, what's supported by the different solutions. Are they regional or are they global? And then what are the supported environments? It tells you what the backends can be. So this is actually really nice to go and quickly understand what are the different capabilities, what security is available. So you'll see the two we talked about, App Gateway and Load Balancer, are not global load balancing. So those services, these are existing in a particular region. So both of these, this App Gateway and the Azure Load Balancer, these are regional solutions. They exist and are resilient just within that particular region. If that region goes down, it's deployed to, it's not available anymore. Now there are global solutions. And kind of like there's different layers here, there are global solutions. So for example, globally at layer 7, it's Azure Front Door. And that has a whole bunch of very similar capabilities where it can do different kind of SSL offload, different types of affinity, it can do rewrites and redirections. So that's kind of a layer 7 global. For a layer 4 global, then there's actually an Azure Global Load Balancer, which is essentially can point to regional regular load balancers. So that's the layer 4. There's also a DNS-based solution. So that is Azure Traffic Manager. Azure Traffic Manager gives you a new name, and then it has different targets that it can point to that would then resolve. So it's a way of, again, balancing between these regional. So if I had different regional deployments, again, I don't want to give a customer different regional endpoints. So I would give them one of these global solutions that, again, would check the health of those different regional solutions and would point them to it. So that's kind of the goal about those. So I'm not going to go into any more detail about that, but if you're interested, that study Cram, the SC700, I go into detail on those. I have a whole bunch of other videos that go into those details. So now I want to shift tact completely. So now let's actually go and talk about storage. So this was all networking, and networking is by far, I think, the most complicated part of Azure. It's networking. Now let's talk about the storage part. I think this whiteboard's getting too big, and this new whiteboard app is struggling with the amount of data I'm writing on this. So I'm going to have different types of data. I might have structured. So maybe it follows a particular type of schema, so I can put that in a database. It might be unstructured. I need to put it just in a binary large object, maybe a data lake. The data could be disks being used by a virtual machine or container instances. So we have different types of requirement actually for our storage needs. But the most basic fundamental building block is a storage account. So if I think about storage, we have this idea of a storage account. Now that storage account has different attributes. So that storage account has a certain name. Now, what's interesting, this is one of the first Azure types of resource. So this name has to be all lowercase and it has to be globally unique. So across all of Azure, this name has to be unique. I deploy it to a particular region. So if I actually go and show this very quickly, we could actually start building one of these out. So if I go and look over here and I just go to storage accounts and I say create, everything gets deployed in a resource group, but you give it a name. Now notice here, if I try and do an uppercase, it complains. Hey, lowercase letters and numbers only between 3 and 24. So I need to pick something unique. If I was to try and do storage 1, I'm going to guess someone's taken that already. So I'd probably use my company name, Savtech SA, maybe my region as part, so I'd grab a naming standard, 01. And that's good. It deploys to a particular region. So I pick the region. Now the region I pick is probably going to be the region where I want to use this service. So it's probably going to be some compute service that's going to talk to this. I'd want it in the same region as the compute service, so I have that low latency, so I have a great connection between them. Now, before I go any further into the properties of kind of the storage account, because we'll kind of look, there's a whole bunch of different things I can do. There are different services exposed through a storage account. And storage account is very, very versatile. So the basic, we have a blob, a binary large object. There's actually different types of blob. So there's block blob, which as the name suggests is made up of blocks. So this is just general data, and this can get really, really big. Then there's a page blob, which as the name suggests is made up of pages, and that's really optimized for random kind of read-write across all of this is very commonly used for disks, because I want to be able to randomly read and write from anywhere. And then there's actually something called an append. And as the name suggests, this is optimized for add operations. So I'm appending to the end of the blob. If I had a log, for example, append would be super, super useful for that. And one of the nice things, remember we talked about role-based access control? Well, this has support for data plane Azure role-based access control. So I can create a role that gives me permissions to operate across block, so I can actually go and do things. Then the next service is files. So if you've ever used like an NFS file share or an SMB file share, that's what files is. So it was primarily SMB, but they do now have the option to add NFS as well. Now for its authentication, it can actually tie into Active Directory. So there's a way I can hook into AD and use that for the authentication. Then we have queues, really kind of a first in, first out experience, some small up to 64 kilobyte in size unit of data, and then tables. So table, there's no schema, but it's really this structured non-relational data. Think about like key value pairs that make up the entities. So it might be easier to just kind of look at one of these super, super quickly. So this is Storage Explorer. This is a free tool from Microsoft, and it's really good to kind of get a quick understanding of these. So if I look at my dev subscription, and I'll look at my storage account, I can see I have different types of service: blob, file shares, queues, and tables. If I look at blob, so blobs are organized in containers. So I have a container called images, and here I can see, hey, I have just these files, they're media files. It can be any kind of unstructured data. If I look at my file shares, well, I have a file share. So this would then be accessible via, for example, SMB in my case here. Now I could also access Azure files through the RESTful API. So I have different options for how to talk to that. A queue is I just deposit some message. So test message 1. And then something else might dequeue the message. So it's a first in, first out messaging. And then tables, there's no schema. It's just sets of key values. And I can have anything I want in here. I've got various ones about the Justice League with different attributes, but you can see I can really add anything I want. So there's existing property names, but I could add a new property name to add it to my particular entry. So that's really useful if I have that kind of requirement. Now, what's actually going on behind the scenes is if I was to look at a storage account for a second, and we look at the same storage account. So likewise, I can see the containers. So I can see all those same things. I could create new containers. I could see my file shares. And notice this is where I could integrate things like Active Directory. And I'll come back to this a little bit. But as part of this, if I add a new file share, notice it's kind of transaction optimized, hot, cool, so I can set different characteristics on there. But depending on the way I'm doing this, I could actually do things like NFS as well when I actually use this. It's one or the other. And that's in my queues and my tables. So there are default endpoints to actually go and get to these various services, but you can actually add custom domains as well. So these are kind of the default different names that I have for my different services in here. But absolutely, some of the things you could do is I could add custom domain names if I wanted to actually have a different name to use for that communication. Now, there's also different actual capabilities added to these services, like a static website. I can actually host a very basic website just by storing it in my kind of blob area. I have configuration where I can go and enable and disable different types of capabilities, but there's a lot of rich functionality to this. So it's way more than just some very, very basic, simple thing. Now, if I was to continue doing that creation for a second, the next big thing you kind of see is this performance. So you see this option of standard or premium. And if it's standard, it's telling me it's going to be a general purpose V2 account. Whereas if I pick premium, now I pick the type of object I'm going to put into this because it creates a different type of account. So when I think about my storage account, in addition to those attributes, well, I also have performance. So again, the standard is really kind of hard disk drive based, whereas the premium is built on kind of SSDs. And it's really not picking up the writing very well anymore. But that's premium, it's more SSD based. So I get lower latency, it's high performance, but then we have to pick a particular type of account. So standard is going to be that general purpose V2. So I can pretty much use all of these types of features. When I do premium, then it's a particular type. So it's either block, so I can only put blocks, or it's page, or it's files. There's no concept of a premium queue or table. You just don't need it. Now, the next thing we have, you might say, was a replication option. And this is really important. So when I think of replication, this is really about the redundancy. So I wrote replication. I think the actual naming on the site is redundancy. Yeah, so redundancy. And there's different options. There's always 3 copies of your data. So if I think for a second, let's dive into that replication. We have the idea, remember, of blue, a region. So I can think about a region. And remember, some regions supported availability zones. They didn't all, but some of them did. So for some of the regions, I actually had kind of those 3 availability zones. And I have a whole deep dive video on availability zones if you're interested. But if it doesn't, just think about it as a certain building. So the different options I have is firstly, locally redundant storage, LRS. So with LRS, there's 3 copies of your data, but those 3 copies of the data is all kind of in the same storage stamp. My next option is kind of ZRS, zone redundant storage. Now, if the region doesn't support availability zones, this won't be an option. But now I still have 3 copies, but those 3 copies are now distributed over the 3 availability zones in that region. So now I've got a better resiliency. I can now think about, remember those paired regions. So there's another region hundreds of miles away where it has multiple data centers. I'm just going to draw one. So my next option for my data storage is GRS. So with GRS, there's 3 copies of the data in one facility. And then there's another 3 copies in a facility in that paired region hundreds of miles away. And then finally, we'll do orange, there's GZRS. So here the 3 copies are distributed over 3 availability zones, but then the redundant region, they're in kind of the same facility. So that's GZRS. And there's also an optional kind of read access variant of those. So what that lets me do is for blob, queue, and table, but not files, I can actually get read access. So if I do the RA variant, then I can actually go and access for reading only that asynchronous. Remember, this is always asynchronous because it's hundreds of miles apart. So it's going to be behind by a certain amount. Now, if you're curious about, oh, how much is it behind this asynchronous copy, you can actually go and look. So if I go back to a storage account for a second, and this time, let's look at my 2. Firstly, we can see the geo replication. So I can see that in there. And it will show me, hey, look, because this is a GRS replication storage account, so I can see that in there, it shows me the primary and the secondary regions. So hey, I can see where I'm replicating, hundreds of miles apart. But if I do prepare for failover, it will actually show me, hey, this is the last sync time. So if I was to fail over now, I might lose that data. Yes, it's Sunday morning. I started recording this just before 6 a.m. I'm in a rush because I've got to take my kids to Dave & Buster's at 11 o'clock. So that's our Sunday fun time. So I started recording this extra early. So this last sync was at 9:17. So I can actually go and look to work out, hey, this is where I am right now. So it is asynchronous, but I can actually go and see. Now there are lots of other capabilities on the storage account. Now I'm definitely not going to go through them all, but there are things like I can enable a data lake. So it makes it a hierarchical namespace. So that actually has true folders rather than a virtual file system that's really just part of the name, which is kind of faking it. So I can actually do that. I can set things like a default tier, the access tier, hot or cool. I can do things like disable the storage account key, which I'm going to talk about in a second. But I can actually go and disable that kind of over here. If I'm allowing public access, there's a whole set of different configurations. Once again, it has the idea of its own firewall and network configurations, as I showed previously. Now, I wanted to double click a little bit into some of the services. So one of the very common things, let's try this again. Let's try it one more time. Okay, I think that's hung. Okay, so this is the brand new version of the whiteboard. It's obviously having a few issues. All right, so we can close that a second. Technical challenges. Let's hope it hasn't lost all my data. So we'll start that again. Fingers crossed. Okay, apologies for that. I had to reboot my entire machine. Again, it's a new version of the whiteboard app. I think they're still working out some bugs. So if I think about blobs for a second, again, they live in a container. And often I'm going to want to get a large amount of data actually kind of into my blob. And there are many, many different tools I can use for that. Like I can absolutely go to the portal and I can upload, but that's not going to work for a large scale. There's things like Storage Explorer. That's that tool I showed earlier. That's like really nice to do that. There's a tool called AZ Copy, which is a really powerful tool that can use multiple threads to do like a bulk move. There's things like DataBox. So DataBox is an appliance that Microsoft will ship to your data center. I plug it in, I can copy data to it over kind of, for example, SMB, NFS, APIs to get data onto it, and then I ship it back to Microsoft and they will read that into my storage account. So if I have a huge amount of data I want to move offline, DataBox is great for that. Or there's DataBox Disk, where it's individual disks. There's also things like Data Factory. So that's a service in Azure that's really a data orchestration solution. it can integrate with blob, but just lots and lots of ways to get data actually in here. Now, when I think about this, for example, the actual data I'm storing, I pay based on different types of interaction. I pay for the amount I'm storing, then I actually pay for the transactions, the interactions. Now, I might have some data that I'm constantly interacting with. And if I want really, really high performance, well, that's when I would pick that kind of premium performance tier. But if I don't need that really low latency top performance, but there's still different ways of interacting. Maybe I integrate a lot, maybe I interact very little, maybe I just need to store it, but I have no intention of interacting with it in any kind of timely fashion. And if I do need to interact, I could wait a few hours to get access to it. So when I think about this, there are actually tiers. So obviously there's that performance tier, which is a different type of account. But then even within just standard, I can think there's a hot tier, there's a cool tier, and then there's actually an archive tier. And again, there's the premium, but that premium tier, that's a different type of storage account completely. So I actually have to create a premium type of storage account. Whereas these three, they all live within standard. So these are all part of kind of my standard storage account. Now the point of this is, it costs more to store it, the higher the tier, but I pay less for the transactions. Whereas archive is super, super cheap, so I could keep stuff for years and years, but I can't interact with it live. I have to bring it back. So if I was to go and look at, for example, one of my storage accounts, so here, if I just pick one of kind of my accounts, let's look at my images again over here. You'll see at a per blob level, I can set the access tier. So I've got some of them in hot, which is the default. I can change that to cool as the default. I've moved one to cool, moved one to archive. And the whole point of this is, so I'm paying less for the archive, for the storage, but I can't actually interact with it. I would have to bring it back to cool or hot, and that might take many hours unless I do a premium move to actually do that. Now I can manually set these tiers. Well, there's actually something nice called lifecycle management. So lifecycle management lets me actually go and I can create rules. And what I can do with these rules is, well, I'll just create some name. Based on, hey, when it was last changed or even just last accessed, I can do different things. Hey, I can delete it, I can move it to cool, I can move it to archive. So this lets me have a kind of automated lifecycle management to use those tiers. So I really think about leveraging that, and I think this board has crashed again. But I could use the lifecycle management to actually interact. So imagine there's lifecycle management now. And what I'm going to do is I'm just going to start a new board because clearly it can't handle the sheer sizes. I apologize. But I will start a new board with this. Okay, so now we have a nice fresh board. In the download below, I will try and kind of put these back together so you can see it in kind of one goal. But the whole point is those different tiers, you can bring them together. Now, another thing I can actually do is we talked about that replication. I can do an actual container object level replication. So one of the nice things I can actually have is imagine I had kind of my blob. And remember that blob can contain different containers. So maybe it's kind of container 1 and container 2. And ordinarily at the storage account level, it would just replicate to the paired region. With object level replication, maybe I've got a storage account 2. I've got a storage account 3. These could be in other regions. And I've got a different container here, and I've got another container kind of here. And what I can do is I can say, hey, this container replicate to there. This container replicate to there. So that is object level replication. So I can be more granular actually in that configuration. So if we go and look at this quickly, so what we see here is under object replication, I can actually set up replication rules. So I can say, hey, this is the storage account I want to replicate to. And from this container, I want to replicate to that container. And I could go and add another rule for a different storage account. So I get a lot of flexibility actually for that different types of capability and what I want that replication to actually be. Now, what this functionality actually does, if I was using this, is there's actually some really nice capabilities actually part of blob. So you have these idea of data protections. Now, I'm integrating with Azure Backup. So Azure Backup is telling it to go and create blob snapshots at certain points in time. But you have this idea of soft delete for containers. So if I delete the container, I can kind of undelete the container. I have soft delete for blobs. I have point-in-time restore. So point-in-time restore lets me go back to kind of any time over the last 14 days. And it does that by using soft delete for blobs, versioning, and a change feed. So if you put all of those things together, I can actually go back to different point in time. So that's a really nice way to actually get protection actually for my blobs. Now, files also has some really great capabilities. So just like blob, files also has the idea of those different kind of tiers. Now for files, it has the idea of kind of, again, there's that performance, different type of account, but then there's kind of transaction optimized, hot and cool. There's no archive. But I can pick that tier based on the performance. And again, I pay differently. I pay more for the storage for transaction optimized, but less for the actual transactions. If we actually go and look at the pricing calculator, we can kind of get an idea, and blobs is kind of the same idea. So we have this idea that, hey, how much I pay to store it. So I pay a lot for premium for the actual storage. I pay less for transaction optimized. I pay even less for hot and even less for cool. But then if we actually go and look at the transactions, well, I don't pay anything for transactions against premium. I pay some for transaction optimized. I pay more for hot and even more for cool. So it's kind of this idea of how am I interacting with the data? I want to try and optimize that. So if I know I'm going to interact a lot, it would probably make sense to have transaction optimized or hot. If I'm just storing it for retention, I don't anticipate interacting with it very much, I can use kind of the cool options. That's going to be the best choice for me. And just like blob, there are snapshots that I can leverage for that, for Azure Files. And as I talked about, one of the other things I can do with Azure Files is for the permissions, I can't do Azure RBAC, but what I can actually do is if I was to go and look for a second, let me find my AD one. If I go and look at my shares, notice I've got this Active Directory configured. So here I've actually integrated it with my on-prem, so regular Active Directory domain services. The storage account actually has an account in my AD. So I can actually now have my AD users connect to this file share and use their AD account, basically Kerberos, and it will enforce the regular ACLs I have on the file. So that's like a really rich way to control those actual permissionings. Now, when I think about on-premises, we probably have file shares already. So I can think about, hey, today on-prem, I have file shares. So I have some file shares sitting on a server. So one of the really nice things we can have, obviously, with Azure, I have this whole idea of a file share. So this is an Azure file share. Basically, a cloud endpoint. Because what I can do is there's something called Azure File Sync. And what Azure File Sync lets me do is I can have one cloud endpoint, but multiple on-premises kind of file shares. I think it's up to 100. And the way this will actually work is these will all replicate against that cloud endpoint. So essentially synchronizing with each other via that cloud endpoint. And it will keep any ACLs I have in there and replicate those as well. It can also do tiering. So imagine I have a finite amount of space on this local file share. Well, I can say, hey, if data has not been accessed over X period of time, just store it on the cloud endpoint, remove it from this server. Or if I get to within 80% of my capacity, start offloading the least recently used content. So that's a really powerful capability when I actually think about, hey, I have these hybrid solutions. If I had a file share on-prem, I want to maybe migrate it to the cloud or give it DR. Azure File Sync to a cloud endpoint is probably going to be the right solution for that. And I've got one of those kind of set up over here. So if I go firstly to my storage sync services, so you create an instance of the storage sync service, you register your on-prem servers to it. It's not good that appears offline. And then what you do is you create a sync group. And the sync group contains a cloud endpoint, so only one, that file share, and then your actual file servers, and it's going to replicate between them. I can see the data going across. It automatically updates the agent. So all of those really great capabilities. Now, I guess while I'm talking about security, realize that storage accounts do have this kind of all-powerful storage account key. So you can go to access keys and you'll see these two keys. It's actually hiding them by default. You get two because the idea is, hey, if I need to rotate them, my application could go and use the other one while I regenerate and then reprogram the other key. But these are all powerful, and I really don't want to use these if I can get away with it. And you'll actually see now there's actually a configuration option that lets me actually turn off using storage account keys. Now, one thing I will kind of stress on this, so yes, we have this idea of the storage account key, and the storage account key is kind of exists at the storage account level. So we have our storage account 1, and we have these two keys, key 1 and key 2. And again, they're all powerful. Now, I can also create something called shared access signatures. Shared access signatures can either be at a particular service level, i.e. just blob or file or queue, or at the account level. So I can pick what services I want to enable. And what you can then do is be more granular. I can limit it to a certain amount of time, maybe from certain IP addresses, certain permissions. But those shared access signatures are signed by those keys. So if I disable these keys, I can't create shared access signatures either. So just bear that in mind. And you can kind of see, if I look at a storage account, I can actually go to shared access signatures. So this is creating an account key. So I can do multiple services, I can pick the permissions, I can pick dates, particular IP addresses, all of those different things, but I have to tell it the signing key. So I can kind of see that in there. So obviously if I disable those keys, I can't use shared access signatures. And then through the APIs, through Storage Explorer, I could actually create service level keys, so it's just for a particular service as well. Again, I already showed you the role-based access control at kind of the data plane. So built in, there are roles for blob and queue and table. So if I looked at, for example, blob data contributor, so we've got that role over there. I don't know what is going on with my portal. I can't see the view button. But you can see, hey, at the data plane, I can actually read blobs, write blobs. So that's a nice way through, again, I could give a group that permission, so they would be able to have that, and it is inherited. So if I set this role at a resource group or subscription, I would have those data plane permissions for whatever lives under that scope. The other thing when I think about security is encryption itself. So the storage account is always encrypted. Now, normally it's a Microsoft managed key, but it is possible to bring your own. So if I've got this storage account and I go and look at encryption, you see I'm using a customer managed key. Now that key lives within your Azure Key Vault. So Azure Key Vault is an Azure service using special hardware security modules to securely store secrets, things I can read and get them back out. Keys, things I can generate inside or import, and then perform cryptographic configurations, operations inside it, but I can't export them. Or certificates, actually distribution of lifecycle. So it stores the key in the Azure Key Vault and uses that to actually perform that at-rest encryption, where it uses it actually to encrypt the encryption key. Kind of the same thing. And what it lets me do is actually enable the latest key. So if I create a new version of the key in the Key Vault, the storage account will automatically pick it up and start using it. There's also encryption scopes. So encryption scopes let me say, hey, maybe I'm using this storage account to run some service that I have different customers. And so I actually want to use a different encryption key for the data of the different customers. So what I can actually do with this is exactly that. I can have a different key for different sets of data and actually leverage that. So this key, for example, I could use for one container. This key may be a different set of blobs. I have all of those different abilities. Now, before I move on past storage, a huge use for it with many things are actually disks. And I kind of talked about, well, page blobs are fantastic for storing disks because it's that page-based random read-write access. And in the old days, we would kind of create a storage account. We would create a page blob. And then inside there would be a VHD. But then we had to worry about limits on the storage account. It wasn't a first-class citizen, that it didn't have role-based access control or images or all those capabilities. So what actually happened is there's now this concept of a managed disk. All of this still exists, but it's completely abstracted away. All I see is the managed disk. Behind the scenes, Azure takes care of storage accounts and page blobs and everything else. Now there's different attributes I think of with a disk. Like with a disk, I think about, sure, capacity, but there's also the idea of a latency. There's also the idea of IOPS, import, output operations I'm performing. And there's throughput, depending on the size of the operation, how much data can I actually pump through. And so there's actually different types of managed disks. There's the idea of kind of a standard hard disk drive. There's the idea of a standard SSD. So that's got kind of single-digit latencies. There's the idea of a premium SSD, even lower latencies, I can get to higher performance, and then ultra disk. So these different types of disks, and again, as you go down, they get more expensive because they get better performance, all those things. Now, to use anything below the kind of the premium SSD and the ultra disk, to use these, I need the S variant. So this makes more sense when we talk about virtual machines. But of a VM, there's like a D series, but there's a DS series. The S means I can use premium storage. So I have to use the S variant when I actually want to use premium SSD or ultra disks. Now, one of the common things in Azure, if I think ordinarily, I could think of kind of capacity and then IOPS and throughput. And the bigger the disk, essentially the higher my IOPS and the throughput will be. They correspond. It's just the way. And that's really for the premium SSD, standard SSD, and the standard hard disk drive. Ultra disk actually lets me have separate dials for capacity, IOPS, and throughput. And in fact, these I can dynamically change. I.e., the disk is being used. I've got some big batch job about to happen. I can crank up the IOPS, crank up the throughput. I'm going to pay more money, but I can change it for a period of time I need it, and I can drop it back down again. So there's kind of super cool individual dials. Some of these disks have burst capabilities. So like I get a certain amount of bursting that, hey, for maybe 30 minutes, I can go to a higher performance for a period of time. I can increase the size of a disk, but I cannot shrink a disk. So imagine I had a scenario where, hey, I need a higher performance for 12 hours. Well, I couldn't increase the disk size because I won't be able to shrink it again 12 hours later. Because of that, what we actually have is if we go and look at kind of a premium disk, so if I look at my disks and I'll pick one, I have size and performance. So one of the nice things I can do is, hey, yeah, you can see the different sizes and you can see the IOPS and the throughput go up. The bigger the disk, the higher these numbers. But I can also set a different performance tier. So here I could change the performance tier to a higher performance. I'll pay for this new SKU, so I'll pay more money, but it's not going to resize the disk. So I could then shrink it again in the future. So I could go up to a higher performance, maybe beyond what I could burst with, maybe longer, higher numbers, but then I can actually shrink it back down again. So that performance tier for kind of the premium is a really nice capability. So that's kind of a key thing we can do. When I think about the types of disk also, for both the standard SSD, premium SSD, and ultra disk, I can do disk sharing. So what that lets me actually do is for all of these, I can share. So there's a certain maximum number supported, generally based on the size of the disk, but I could have multiple VMs connect to the same disk. And it supports things like SCSI persistent reservations, so it can actually be used as a clustered disk. So things like cluster shared volumes on Windows, I could do that. The exact numbers, again, vary. If we look at the documentation, it will tell us how many I can have. So here we go. So premium SSDs between 3, 5, and 10, depending on the size. Standard 3, 5, 10. Ultra between 1 and 5. It doesn't really matter about the size because, again, it's different dials. We can really do anything we want. One final point. Disks have a performance set of characteristics, IOPS, throughput. You're going to connect them to a resource. That resource will have its own limits of IOPS and throughput. So remember, when we're trying to balance the right combination, I have to actually tie them together. It's no good having some massive number of IOPS and throughput on the disk, and I've got a tiny VM that can't use that amount. So you need to look at the limits of the VM to make sure it matches the limits of the actual disk you're trying to attach to it to actually make it work. Okay, so we've got storage, we've got networking, we've got the identity governance. Obviously, we kind of now get to compute. And again, I'm going to try and stitch these two whiteboards together. It's unfortunate I had to start a brand new one. That can be some feedback to the new whiteboard team. So when I think about compute, there's different layers. So I can think about, well, there's storage, there's networking, there's compute, there's a hypervisor, there's the operating system running on the virtual machine I create on the hypervisor. There might be different runtimes like .NET and J2E. There might be some middlewares. Then I have my app and my data. And this all comes down to different types of service that we can have. Like if I'm on premises, for example, I'm essentially responsible for all of them. That is me as the customer. I might have different teams, but ultimately I'm responsible for all of those things. When I start looking at the cloud, we kind of start with IaaS, infrastructure as a service. And we get this line. So now the vendor, in this case Azure, is responsible for the fabric, the hypervisor. I don't see any of that. What I get is a certain service exposed to me. In this case, it's a virtual machine. So essentially, I'm getting a VM. then it also means I'm responsible for all of the things associated with that. I'm responsible for thinking about high availability and DR and backup and patching and configuration. I'm responsible for all of those things. Now, there's things to help me, but I'm responsible for all of that. Then we start moving into, well, there's like platform as a service. Here, the line's all the way up there. So now, there might still be VMs, but I don't see them really. I might see them in terms of a sizing. I pick the size of the SKU I want, but really my responsibility is for getting my app deployed. That's my function. Now, there's different types of services moving through here. We have things like virtual machine scale sets. We have Azure Container Instances. We have Azure Kubernetes services. We have app services. We have things like serverless offerings, like Azure Functions, Logic Apps. So there's all different types of service. We can kind of get more and more PaaS-y. And then there's software as a service. This would be where the vendor is entirely responsible, like Office 365, Microsoft 365. I'm not installing Exchange or SharePoint or patching those things. It's just kind of done for me. Now, as I think about these, and let's kind of focus in for a second. Let's start with virtual machine. So a virtual machine is really kind of a basic. We get some VM. And think about what that VM is. That VM has certain characteristics. Now, it has a certain number of CPUs. It has a certain amount of memory. It has certain storage characteristics that it can support, storage, IOPS, throughput. It has certain network connectivity. It might have special requirements like GPUs or RDMA network adapters or NVMe storage. But this workload has a certain shape. So this VM is doing some work. Now the work coming in, when I process that work, there's certain resources I require. Now those resources are going to be in terms of, well, how much CPU, how much memory, what is the storage look like, what is the network, these other dimensions. And it's really about different ratios. So I can think about, well, what's my ratio of CPU to memory, for example? And different like databases might need a lot more memory than CPU, whereas some app layer might be very CPU centric, or maybe I have some balanced mix. So the whole point here is Azure has a whole set of different virtual machine sizes. And they're based about the different types of workloads. So I could think about, well, actually we'll start with compute optimized. So if I was to look at compute optimized, what you can kind of see here is, look, the more CPUs I get, the more memory I get, the more temporary storage. So the attributes go up together. But essentially for these compute centric, there's a ratio of 1 to 2. So for every 2 CPUs, 4 gig of memory, 4 CPUs, 8 gig of memory. So it's a 1 to 2 ratio. Then there's general purpose, and notice these S variants, which means they can use the premium storage. If I look at general purpose, well, it's a 1 to 4 ratio. 2 to 8, 4 to 16. Okay, so it's more balanced. Then there's memory optimized SKUs. Here, it's a 1 to 8 ratio. So there's all these different families. And again, as the VM gets bigger, I also get more storage, I get more network performance. Everything kind of goes up together because I'm getting a bigger portion of the underlying host that it's actually running on. Some have burst on storage, some have burst on the VMs. Like the B series, I can actually burst the virtual machine as well. Now, if I think about the actual resource, it's not running on thin air. So it's running on a host. There's a particular box that this is running on. So there's a host this runs on. Now what happens is that host has sets of resources as well. Now that virtual machine, for example, for its OS, connects to a managed disk. I might also connect to data disks. multiple data disks I can connect to. The host itself also has local storage. And what it does for most of them is it creates a VHD, a virtual hard disk, and it maps that to the VM as well as kind of a temp, a scratch drive. So it's not durable. The managed disks live outside of the host. There's 3 copies of the data. They can even be zone redundant. So if something happened to the host, I've not lost the content on my OS and data. This temp drive lives on the host itself. So if something happened to the host, well, I would lose the content of it. But it's really low latency, high performance. So it's great for a scratch area. I just need somewhere to write to, but I'm okay losing the content of that. So I kind of use these things together. Some of these boxes have NVMe local storage, like the N series VMs use that. Some of them have GPUs. The NV series, they use that. So this is the L series. This is the various N series. There's high performance that have RDMA network adapters. So there's different types of VMs based on my requirements, based on those ratios of CPU to storage. There's all different ones to actually meet my various needs. I pay for when it's running. So shut things down, deallocate them when I know I don't need it to stop paying for it. I can use the pricing calculator to really go and work out, hey, what is this actually costing me? If I know I'm going to run something for a period of time, well, you can do things like reserved instances. This is the pricing calculator. I can say, hey, I want to do pricing about a virtual machine. And here I can go and work it out. I can say, hey, what's the size of the virtual machine? It's showing me the price per hour. But again, I pay for the seconds it's running. But notice this. If I know I'm going to be using these for 1 year or 3 years, and I know I'm going to have 20 or 50, I can do these reserved instances so I get a big discount. But obviously, I need to make sure I'm paying for those. And again, I go into detail on this in the Azure Pricing Calculator video. Creating a VM is super, super simple. Now, there's disks that are kind of built in to the gallery. So I can create Windows, I can create Linux. I see some standard images that it's kind of presenting to me here, Windows, Linux. I can pick the size. I create it in a region. Obviously, the disks are going to be in the same region as the actual virtual machine. So you can just go through, create a VM. Just make sure you stop it when you're not using it to save yourself money. Make sure if you don't need it anymore, you delete it. So notice here, I've got this stopped deallocated. That means I'm not paying for the compute, but I'm still paying for its managed disks. So that's why it's a really good idea to create resources in resource groups together, the storage, the disk, the VM. Then when I know I'm done with it, I can delete the whole resource group, and then I don't leave some disk behind that's costing me money. So really make sure you think about all of those different resources. Now, when I drew this picture, I had this idea of responsibility, and I was like, all these negative things like backup and patching and config, well, there are things to help me. For virtual machines, we have the idea of extensions. And they perform certain functions. So for example, if I go and look at some of my virtual machines, we can go and look at extensions. And there, I've got a huge number of extensions here, like anti-malware. There's a huge library of extensions I can leverage to perform certain functions for my environment. Some really nice ones is custom script extension. Here I can easily run a PowerShell script or a Bash script if it's Linux to perform some set of actions. There's things like PowerShell desired state configuration to have a declarative configuration to deploy into that guest operating system. So that's a really powerful. So these extensions are really useful to actually go and do configurations and help me manage these environments. I don't have to manually go and do things inside them. Even things like backing up. Well, there's the Azure Backup service. And what I can actually do, if I do backup for a second, one of the nice things we can do with backup is I can create a policy. So an example, if I create a backup policy over here, I might have a virtual machine policy, And my policy might say, hey, I want a daily backup that I want to retain for a certain number of days. But then I also want to retain a weekly backup for a certain period of time, and then a monthly backup for a certain period of time, and then maybe even an annual. I don't know why this is taking so long. But I have these different options, and then it will go and do those backups. It will orchestrate that, and it will kind of orchestrate that retention as well. So here we can see, hey, I've got the daily I set, keep it for 30 days. But I could also say I want to keep a weekly for 12 weeks, a monthly for 60 months, an annual for 7, 10 years, whatever I want. And the policy will go and make that so it's doing Delta-based storage into this vault. So this backup capability is super, super powerful. So that's a way I can help and actually go and do the backup. There's also Azure Backup while I'm here. Sometimes it will orchestrate a solution, but doesn't actually copy the data to the vault, like file shares. Here I've got a policy that what it will do is go and take a snapshot of the file share and keep it for 30 days. But it's not actually copying it to the vault. It's actually just going to use the native Azure file snapshot capability, for example. I think it's over here, I've got that running. It will just use the native capability. So if I was to look at this and my file shares, and let's say I looked at images, look at all these snapshots. Well, they're actually taken by Azure Backup. And then it will go and clean them up based on that retention period. So it's not copying the data to Azure Backup, but Azure Backup is creating the snapshots, retaining them, and then deleting them once I get past that period of time. So the recovery vaults really help bring and manage all of those different things. Now, if I'm creating virtual machines, I probably want to get to my virtual machine. Yes, I can give it a public IP. I really don't want to do that. I should not be RDPing or SSHing or WinRMing over the internet. You're going to get hacked within a couple of hours. So it has a private IP. Remember, if I'm connected via site-to-site VPN or ExpressRoute, I can connect to the private IP. If I don't have that and I do have to connect from the internet, there's actually something called Azure Bastion. So Azure Bastion provides a managed public-facing service integrated with the portal, so it's not exposing any direct IPs, and then I can go and connect to any resource in the VNet of the Bastion or any peered VNet. So if I was to go and look, I have Azure Bastion deployed into my subscription. So if I look at my Bastion, so I have Azure Bastion in my South Central network. What that lets me do now is if I go and look at a VM, even in a different region, but it's on a network that's peered to my South Central network, if I do connect, I can say connect via my Bastion. I want to use Bastion. It works out where there is one. Then I would just give it the various credentials. And if I do connect, it's actually going to go and connect in the browser to that virtual machine. So now it's not exposing anything directly from this. I could have conditional access on this to have things like MFA. So this is a really nice solution that I can now light up. I have it in a VNet, and I can even go and use it from other virtual networks as well. Now, while I'm thinking about just a virtual machine, realize that virtual machine is on a certain host. That host fundamentally is on a certain rack in a certain physical building. So I can think about that rack as a fault domain. Something could go wrong. Top of rack switch, the power supply unit, it could break. So one of the ways we can think about making things highly available is within the different data centers, there's lots of racks. And what we can actually do is we can think about, hey, look, is this fault domain 0, fault domain 1, fault domain 2? I can create something called an availability set. And when I create an availability set, let's say it's 3 fault domains, when I add resources into that availability set, it will go and distribute them over 3 racks. Now, the other thing it actually has, so I'm now resilient against a rack failing. What it will also do is it has something called update domains. So you can imagine these are actually different blades in the rack. So when it applies updates, I can have between 5 and 20 update domains. It would only take down a fifth at a time as it goes and rolls out updates to that actual area. So those are actually really powerful to use. Realize this is just distributing them. Do not mix workloads. If I mixed my domain controllers and SQL servers and web servers in the same availability set, through sheer bad luck, all my IIS might be on this rack, domain controllers on this one, SQL on this one. So what I would do is I would have, okay, I'll have an IIS availability set, and I'd put all my IIS servers in that one to get them distributed. I would have a SQL availability set, a domain controller availability set, to make sure those things are distributed. Now remember though, those things are all within the same kind of physical building. Remember I talked about the idea of a region. Well, that region is actually made up of, in some cases, different physical facilities that have kind of that isolated power, cooling, and networking. So if my region supports availability zones, this is a nicer option. Because whereas availability sets give me resiliency against a rack level failure, well, this gives me resiliency actually from an entire facility having some kind of failure. So I want to think about use those if I can. And again, make sure we deploy to multiple regions if we can for even kind of better resiliency. Now, building up from virtual machines, I can create VMs. I can create an individual virtual machine. But what would be nicer is I want some unit that will go and create them for me based on some template. So we have the idea of a virtual machine scale set. So I have some disk template that maybe is the OS, maybe it has some app on it. I have some configuration, maybe it's extensions to go and install certain features or do certain things. Also, it's a certain kind of VM size. Maybe it's spot VMs, which are cheaper. Maybe it's not. Maybe I have a minimum number, maybe a maximum number of instances. Maybe I even have auto scale. I can have rules that say, hey, look, if the CPU is greater than 70% average, add 2. If the CPU is less than 30% average, remove 1. And then it will go and add and remove them as I need to. And this auto scale is a key point in Azure. On-prem, we might have 10 instances, we run them all the time. Why not? We bought the hardware, it's sitting there. In Azure, I pay per second of it running. So if I think about, hey, I have kind of time and I have load, well, imagine it changes. So imagine right now I've got a medium. Well, I want 3 instances of my app running. Then I get busy. Oh, okay, I should add 2. Then I get really quiet. Okay, I should delete 3 of them. Okay, now I get busier again. I should add 1 back. That's auto scale. So this is kind of this horizontal scale. I'm adjusting the instances I have to match my workload. And that's what's going to really make me optimize the money I spend. So that really is a key point. So a minimum, I really want to not use VMs on their own. If I have multiple instances, which normally we will, it's a web service, it's something, I want to use virtual machine scale sets to automatically create and adjust based on the numbers I actually have. And if I jump over, it doesn't have to be CPU. If I look at my VM scale set, in my example here, again, I can set instances. I have just 1 running right now. In the scaling, I can kind of say, hey, I'm actually scaling based on a metric. So mine says when a queue depth is greater than 5, if I look at the rule, if it's greater than 5, increase the count by 1. If the queue depth is less than 2, decrease by 1. I have between 1 and 5, so I'll only go up to 5 instances. So I can configure all of these things. And again, I base it on a certain size. I have certain configurations. So this will go and auto scale exactly what I have actually based on that. So I can think about, okay, VM scale sets, they're good. They're getting me beyond just basic virtual machines. If I keep going up the stack, VMs virtualize the hardware. They split physical boxes into units of CPU memory aspects. Then we have containers. So what containers do is containers actually kind of virtualize the operating system. So I can think about, I have a container host. And there's obviously an OS running on this thing. They have a container runtime. Maybe like container D, something like that, which basically creates these sandboxes, these isolated environments where I can run containers. So the containers will actually run in each of these things, and they're generally isolated at a user mode space. They're running on the same OS instance, so a shared kernel, but each of them has these kind of isolated namespaces, networking, controls around there. And the way this actually works is what we typically would actually have is we have a container registry. So there's Azure Container Registry. This is where we store images. And the way this actually works is what a container is we might have maybe some base OS container image that was generated by the OS provider. And then we have a composition file that says, hey, I want to build on this image and then run these various commands to customize it. This is kind of a Docker file. And the output of this is our new custom image that's our application. Then I'm going to run that in a container instance. So that's how these kind of things run together. This I could run as a VM, sure. But at a really basic level, Azure has something called Azure Container Instances. Hey, I can go and run my image in here. It actually uses like a special type of virtual machine, so I also have kernel mode isolation from anyone else running on there. Obviously, that's important in a shared environment. And I can see this. So if I jump over, firstly, if I look at my registry, let's do container. I created my own registry of my own image, actually in there. So I have an image, a container image. And then if I look at my container instances, I actually don't have any in this one right now. Actually, maybe it's over in this one. Too many subscriptions. No, it's not there either. Okay, well, I could easily create one. And basically, all I have to do is give it a name, a location. I could say I want to build it off of an image I have. I can give it a size, and it will go and actually create a container for me that is public facing, as a public IP. So it's a super easy way to get up and running with a container. But the challenge is, if I start to think at a bigger scale, there's other things I need for containers. Like I want multiple instances of my containers. I want to auto scale them. I want to be able to have these rich deployments of multiple layers, which I can't easily do with Azure Container Instance. So what we actually get to next is things like Kubernetes. So Kubernetes is a CNCF standard as a container orchestrator. And what this does is I could just, again, deploy Kubernetes to virtual machines if I wanted to. But there's a lot of work to actually set up Kubernetes. So what we actually have in Azure is Azure Kubernetes Service. So this is a managed Kubernetes environment. Now there's a whole set of control plane to Kubernetes. So there's a whole management set of functions. For example, I can think about, well, there's an API server that we actually interact with. There's an etcd database for the state. There's a scheduler that goes and looks at, well, what pods do I need? Pods is the container for containers in Kubernetes. Containers run in a pod. There are various controllers. There's all of these things. So these are just done for me with AKS. I don't see it. It's just a managed service. What I get is I have my nodes. So I specify sizes, and I get kind of my node pools, which are nodes of certain types. So these are just boxes. They run the kubelet, which is, again, is a standard part of Kubernetes. And again, look at the video in the playlist for details. I'm not going to go, there's too much detail to try and go through all of this. But these essentially go and talk, and this is all managed for me. And then essentially I just get my pods. So I have a pod that runs my various container workload within there. There's different types of networking. There's KubeNet, where the networking is all abstracted from the underlying virtual network. It uses network address translation. There's Azure CNI, where I actually get real IP addresses for the pods. This is container networking interface from the actual real VNet. There's different load balancer integrations like load balancer, App Gateway, third parties like Nginx. I can have persistent storage. So I can absolutely, in a pod, say I have a persistent volume claim, which is, hey, I want to use some persistent storage. That maps to a persistent volume, which is of a certain type. This could be Azure Files, standard or premium. This could be an Azure disk. So then that pod will see that storage, so it can store things for a long time. There's autoscale native to all of this. So there's kind of this idea of pod autoscale. So if the work on my pods varies, well, I can add and remove pods based on the need. And then based on adding and removing pods, that scheduler will say, hey, I've got pods that need to be scheduled and I've run out of space. So it actually can then do autoscale at the cluster level. So based on the availability of scheduling pods, there's a cluster autoscaler to actually add and remove nodes from the node pool based on my ability to schedule the pods on the hardware. So there's those capabilities as well. So there's huge amounts of things here. And then you can kind of keep moving up. Then there's things like app services. So app services is kind of how actually Azure started. These are all kind of HTTP, HTTPS, web apps, mobile apps, API apps. And what I do is I create an app service plan, which consists of various resources. Maybe it's a certain number of boxes. And then I can deploy it onto that app services, which is a particular instance of an app. And there's different SKUs available. So for example, if I look at the different plans, they have different capabilities. So here I can see, hey, there's the basic, there's free. So I can actually create an app service plan that's free to play around. It's shared compute. Then there's like basic and standard. Standard is where we start getting features like autoscale. So I have to get to that standard SKU. I can have different numbers of instances. We get things like private endpoint support we talked about, custom domain names, deployment slots. So deployment slots are the idea where, hey, I can think my app has a production instance. So maybe I have, hey, I can run multiple apps on the same plan. So this is my app to production. But I can also maybe create an app to staging. It's using the same hardware, but then I can kind of deploy my new code into staging, warm it up, test it, and then when I'm ready, I can swap them, VIP swap, virtual IP swap, and then make this production. And then if I needed to, I could roll back very, very easily. So this gives me a lot of capability that, again, I can really focus on my app. There are things like app service environments, where I have entire dedicated sets of hardware into my virtual network. A normal app service plan, although the nodes are mine, there's another set of components that are actually shared between multiple customers. It's still isolation, but they're shared components. So it makes it a bit more difficult to integrate things like virtual networks. I have to use private endpoints per app. At the app service plan, I have to do VNet integration, for example. Whereas if I use an app service environment, it actually deploys into my virtual network. So it's kind of completely isolated. So lots of different capabilities around there. And I've been recording for a really, really long time now, so I'm going to kind of, to finish off super quickly, monitoring. Now that's a really important point, but for all of these different things, again, I'm going to try and stitch these whiteboards together somehow. We obviously have monitoring. And there's monitoring at all different levels. There's monitoring when I think about performance and metrics. There's logs. I showed you the subscription activity log before. So I can think about, hey, I have my subscription. The subscription has its own activity log. So that's things happening at kind of that Azure Resource Manager fabric level. And then I can think of individual resources. Well, resources have metrics, and then they have logs as well. Now what happens here is metrics, by default, just go to Azure Monitor Metrics. I can just see these. I don't have to do anything special. They are just there. If we go and look at a resource, and let's just pick, virtual machines are actually quite nice, or storage accounts are nice as well. But I can just go and look, monitoring metrics, and I see a whole bunch of metrics from the VM host. I can see disk IOPS, bandwidth, I would see storage account things, all different things available for this. So I can see all these different types of counters available for me. And again, these operate across all different types of resource. If I picked, for example, SQL database, it has, and it's actually showing me some on the main page right at the start, some of the more common ones that I might want to see. But it has a whole set of metrics as well that I could go and look at and see information about the resource. So metrics are just available natively. But then we also have this idea of logs. Now logs are not stored anywhere by default. So what I have to do for logs is, for logs we have this idea of diagnostic settings. And I can centrally manage these through things like Azure Policy. So diagnostic settings lets me say, hey, there might be different types of logs. I want that log and that log. And I can also capture metrics. And I want to send these to some target. And that target could be storage. Storage is good for long-term retention. It's cheap, but I can't do a huge amount with it. I might want to send it to an event hub. An event hub is a publish subscribe tool. That would be really useful if I had some external SIM that I wanted to actually go and fetch those so I could read it into the external SIM. Or I could do a log analytics workspace. That's kind of like the premium Azure solution for the ingestion of really any kind of data. And I can then use a Custo query language to actually perform analysis of it. I can create these nice dashboards. I can get this cool view of it. So I can then go and actually send the data. So again, on this SQL, while I'm here, I have diagnostic settings. I can now go and add, okay, yeah, I want to capture these logs. There's all different ones. I can capture certain metrics. And where do I want to send it to? Okay, event hub, storage account, log analytics workspace. So we have those different hooks to actually send the data to different locations. And once it's in log analytics, like there's a ton of different things that build on top of that. For example, something native is you might see sometimes this idea of, let me actually look at a different resource. If I pick a virtual machine, you'll often see something called Insights. So Insights is a curated view of the resource, and it's built on top of Log Analytics. But here, for example, it's got this kind of map that it's worked out. I can see basic performance information about it. This is all gathered through there, built on top of Azure Security Center, Azure Sentinel, use things like Log Analytics. So there's many solutions built on top of this. So the whole point is I have all these kind of great pieces of information going to this Log Analytics workspace. And then what I can actually do is activity logs, Azure Monitor metrics, and this Log Analytics workspace. I can then actually create alert rules. From any of these kind of signals. So logs in Log Analytics, a metric, something from the activity log. And then if it triggers, I can then fire an alert group, which is a set of things I want to do. This could be SMS, it could be send an email, it could be fire off a function or a logic app or an Azure automation or webhook. Do some stuff to actually react. So if we look at that, so what we can do is we can go and look at Azure Monitor. We can go to alerts. So firstly, we can manage our alert rules. And we can see I'm going to have different types here. So I'm going to have some alert rules that are based off, you can see the signal type on the far right over here. So I have some based off of metrics, some based off of a log search, some based off of my activity log. Then I also have things like smart detectors. So there's some more advanced things we can actually do. Service health. So the health of my resources is another input I can have. So I can create these rules. So like dir sync over 50% CPU. So I can have actions, the alert rule details. I can actually modify the condition. So it's showing me historically. And then I can create an alert rule. Now this was me setting a definite real number. There's also dynamic rules. So with dynamic rules, it actually uses machine learning to look at what's common. And then I could say, how aggressive do I want to be? So it's going to look at the history, and it could be medium sensitivity, low sensitivity, or high sensitivity. And you see that it's changing. It's showing me what it's going to start alerting on based on history, how sensitive I want to be. So I can also do those kind of dynamic rules. It doesn't have to just be a single number. And then it calls an action group. So an action group is some combination of things to do. Email, SMS, push, voice, Azure Resource Manager role, communicate. Also, hey, run a runbook, call a function, integrate with an ITSM like ServiceNow, call a logic app, call a webhook, call a secure webhook. All these different combinations of things. There's more advanced things I can do with action rules, like, hey, if I see an alert at a certain resource group, do this, or I could suppress. So there are other things I can do. But that's really kind of a key point. And I guess while I'm in here, a final thing I want to show is Network Watcher. So here we can see I've got Network Watcher instances on different regions. And then we can do things like look at the topology. I can check IP flow. I can do diagnostics around network security groups. I can work out what the next hop would be for these communications. I can work out the effective security rules. I can do packet captures. I can capture network security group flow logs that then let me do traffic analytics to look at things like, hey, common partners that talk, hey, bad traffic coming from particular regions. I can do a whole set of really advanced stuff. So again, make sure you kind of go through these and understand exactly what these are doing. So that was it. I think that's so much content. I apologize. I knew this video was going to be long. But go through the Microsoft Learn modules of this. I created that playlist. I would go through that playlist. I would maybe watch this just before the exam, but get the hands-on. I think that is the key point to be successful. You need the hands-on, know how to do it from the portal, understand there's like CLI commands as well. So try the different methods that it talks about in those things. Take your time. If you don't pass the first time, go back and look at where you did weak and go and restudy those areas. And I'm sure you'll get it the next time. I really hope this was useful. A huge amount of work goes into this, so please do like and subscribe. But good luck. Until next time, take care.